Hello, friends, and welcome back to the Snoozy Scientist, where we gently explore the mysteries of our world, one sleepy yawn at a time. I'm so glad you've chosen to spend a little piece of your evening, your morning, or perhaps somewhere peacefully in between, winding down with me. Tonight, we are traveling to a continent that remained unrecognized until recently, a landmass so vast that its absence went unnoticed on the global map, Zealandia. For centuries, we believed the map of our world was complete. Yet in the year 2017, a formal geological assessment challenged that certainty, drawing attention to subtle signatures on the seafloor. These pieces formed a shape too large to ignore, suggesting a landmass that once stood proudly above the waves. What emerged was the possibility of an entire continent, larger than India, concealed almost entirely beneath the ocean. 94% of it rests underwater, leaving only scattered peaks at the surface, with no written memory, no preserved ecosystems, and no human story to mark its existence. Magnetic readings, satellite gravity maps, and deep sea surveys eventually converged on the same quiet conclusion. This was not a scattered collection of fragments, but a coherent continent, one that once rose above sea level long enough to host forests, rivers, and life that has never been recorded. Its disappearance reshapes the understanding of plate tectonics, sea level change, and the deep time processes that sculpt the planet. Yet the continent itself remains silent, leaving only broad outlines and scattered geological signatures to hint at the world it once was. But what forces were powerful enough to erase a continent from the surface of the earth? What kind of world existed on this land before the ocean reclaimed it? How can an entire continent slip from the human story so completely? And what else has our planet erased long before we appeared? Tonight, we drift toward the faint outlines of this drowned world, letting science and silence guide us deeper. But before we begin, if you find comfort in these quiet journeys through science and story, it would mean the world to me if you gave this video a gentle like and maybe tap subscribe. It helps more curious minds like you discover this peaceful little corner of the internet and lets the algorithm know that sleep and science belong together. And if you'd be so kind, let me know in the comments, where are you listening from tonight and what time is it there? I love seeing how far these soft explorations travel. Now take a deep breath, let your shoulders soften, close your eyes if you'd like, and together let us step softly into the mystery of the continent that nearly vanished from Earth's memory. When we speak of continents, we often picture the familiar shapes that rise above the oceans, broad stretches of land, layered with soil and forest, shaped by wind and water, and the long patience of time. Yet beneath this everyday idea rests something deeper, something the planet has been quietly shaping since its earliest chapters. A continent is not defined by the life that walks upon it, nor by the nations that draw their borders across its surface. It begins with the crust itself, the solid skin of the world, rising and falling in slow rhythms that stretch far beyond any written record. If we could peel back the waves and look at Earth from within, we would see that not all crust is the same. Some parts are dense and dark, formed from heavy rocks that sink low and welcome the oceans above them. This is oceanic crust, born from molten seams along the seafloor. It spreads outward like a quiet conveyor, cools, thickens, and eventually slips back into the mantle where it began. It is young in the language of geology. Most of it has aged for only a small fraction of Earth's long history. Its story is one of endless renewal, rising from fire and returning to it again. Continental crust tells a different story. It is lighter, thicker, and far older. Much of it carries memories that reach back billions of years, into times when the atmosphere was young and the earliest continents were only beginning to take shape. Continental crust resists the pull of the deep mantle. It floats higher, much like a wooden raft rests above a lake. This buoyancy allows it to support mountains, valleys, and rivers, and it lets entire landscapes stand above sea level for ages that feel almost unimaginable. Scientists rely on these differences when they trace the edges of a continent. They look for a crust that is thicker than the floors of the oceans, and for rocks that formed in ancient processes of heat and pressure, not in the quick fire of the mid ocean ridges. They measure density, composition, and the way the crust bends under weight. They study the shapes of basins and mountain roots, and they listen to the signatures held in minerals, each one a quiet record of fire, water, and time. A continent, in the geological sense, is not simply land. It is a coherent block of this older, lighter crust. It has a structure that holds together through deep time. It may rise or sink, fracture or drift, but its identity remains, carried in its foundations. Scientists look for continuity, for pieces that fit together in a single geological story. They examine magnetic patterns that reflect its birth and the slow movements that have shaped its life. With this understanding, the familiar map of the world becomes something richer. The edges of a continent do not always match the edges of the shore. They often stretch far beyond the beaches, hidden beneath shallow seas, or resting below gentle continental shelves. Entire regions we consider part of the ocean floor may, in truth, belong to continents whose highest peaks just happen to touch the air. Zealandia lives within this quieter truth. Although most of it rests far beneath the surface of the Pacific, its crust tells a story that is unmistakably continental. It is thick compared to the deep ocean floor, and its rocks carry the chemical fingerprints of ancient mountain building. The fragments that rise above the waves, the islands we know today as New Zealand, and a scattering of smaller ridges are only the tallest summits of a much larger whole. When scientists first mapped the region in detail, they noticed wide plateaus rising gently from the ocean bottom. These were not the sharp volcanic slopes found across much of the Pacific. Instead, they had the soft curves of continental shelves. Magnetic readings revealed patterns that aligned across hundreds of miles, and samples taken from the seafloor carried minerals that formed in ways only continental crust can. As the evidence accumulated, a picture slowly came into focus. Zealandia was not a chain of isolated fragments. It was a single coherent continent that had thinned and sunk over tens of millions of years, leaving only traces at the surface. Its submergence does not disqualify it. A continent can rest beneath the sea and remain a continent all the same. What matters is the nature of the crust, its origin, and its coherence. Zealandia meets each of these quietly, almost shyly, as if it had waited for human understanding to catch up to its gentle outline on the seafloor. A continent becomes not only a shape we can walk upon, but a deeper structure shaped by ancient heat and slow movement. It is the part of Earth that endures longest, carrying echoes of worlds long gone. Zealandia, though mostly drowned, belongs to this lineage. It is a reminder that the planet keeps more secrets than its surface suggests, and that even the oldest maps may yet have room to grow. As researchers continued to map our planet with tools far more sensitive than those of earlier generations, a quiet shift began. It did not start with a dramatic announcement or a sudden revelation. It arrived slowly, through measurements that whispered of something unusual beneath the Pacific. By this point in our story, we have already drifted through the idea that continents are defined not only by the land we see, but by the ancient crust that supports them. Now, we follow the moment when those foundations began to reveal an unexpected outline. The first hints appeared in satellite data, gathered high above the moving waves. These satellites measured gravity across the globe with remarkable precision. When their readings were transformed into glowing maps of the ocean floor, slight variations shimmered across the screen. Most of these variations were well understood. Underwater mountains created gentle rises in gravitational pull. Deep trenches created subtle dips. But spread across a vast region east of Australia, the pattern changed. Instead of sharp peaks or narrow ridges, wide swaths of higher gravity seemed to flow together like faint brushstrokes on a canvas. At first, these anomalies were met with curiosity. They suggested thicker crust beneath the water, crust that behaved more like the foundations of continents than the darker, heavier rock of the deep ocean. Yet curiosity alone was not enough. Science moves slowly, with care and patience. So researchers gathered more data, watching as these gravity patterns reappeared in survey after survey. Each pass of the satellites added a little more confidence, a little more shape, like the gradual emergence of a coastline in morning fog. Alongside the satellite readings came the detailed mapping of the seafloor itself. Ships glided across the Pacific, sending sound waves downward. These waves returned carrying stories of depth and contour, etched into the ocean floor like memories carved in stone. When the maps were stitched together, something striking emerged. The seafloor did not simply rise and fall in the chaotic style of volcanic terrain. Instead, gentle plateaus spread across thousands of miles, connected in a way that felt unexpectedly orderly. These were not small features. They were broad and sweeping, their proportions far too large to ignore. The shape suggested the surface of a submerged landmass, one that had thinned and settled into the ocean over ages. The contours rose like the faded silhouettes of once towering landscapes, softened by time and the weight of the sea. As these maps improved, they began to outline a region that seemed almost to breathe beneath the waves. It was as if the ocean itself was hiding the quiet imprint of a continent that had slipped beneath its surface long before the first human gaze ever crossed these waters. Within the geological community, a ripple of surprise moved quietly from lab to lab. For decades, the idea that the map of Earth was complete had been treated with comfortable certainty. Every continent had a name. Every landmass was thought to have been measured, studied, and understood. Yet here was a region larger than India, resting mostly underwater, presenting evidence that did not fit the old picture. Geologists gathered at conferences and workshops, sharing figures and theories, pointing at maps where the outlines of this hidden land began to glow with clearer edges. It seemed to rise in the data like a half remembered story, one that had waited patiently for modern instruments to reveal it. Conversations grew livelier. Some researchers traced the magnetic signatures that ran across the region, comparing them to the patterns seen in known continents. Others examined rock samples dredged from the seafloor, finding minerals that formed far from the fires of mid-ocean ridges. What unsettled many of them was not the presence of the crust itself, but the scale of it. This was not a minor shelf or a scattered collection of fragments. It was an enormous block of continental material, stretched thin over time, yet still unmistakably unified. Its size alone forced a rethinking of familiar assumptions. If something so vast could remain unrecognized for so long, then perhaps Earth still held secrets beneath the surface of its own oceans. Little by little, a consensus grew. A continent did not need to rise high above the water. It only needed the ancient roots of continental crust, a coherent geological story, and a structure shaped by the same deep processes that built the great land masses we live upon today. Zealandia, as the region came to be known, carried all of this quietly in its submerged stones. For the scientists who traced these patterns, the realization felt like watching a curtain lift on an unexpected landscape. The world had seemed complete, and then it shifted gently under their feet. In that shift, a continent emerged, not newly born, but newly seen. The discovery did not end with a single moment of triumph. It unfolded slowly, through data and dialogue, through shared wonder and lively debate, until the outline became too clear to deny. And with that clarity came a simple truth. Earth had held on to one of its greatest secrets beneath the Pacific, waiting for the day when human eyes could finally read the story written in the quiet gravity of the sea. For a continent to disappear from human awareness, it helps to be hidden beneath a vast and restless sea. By the time modern scientists began to question the familiar outlines of the world map, nearly all of Zealandia rested far below the waves. Only a scattering of rugged peaks remained above water, the tallest fragments of a once broader landscape. These islands, clustered around New Zealand, carried pieces of the story, but never enough for anyone to imagine the scale of the world that lay beneath them. For much of scientific history, researchers relied on what could be seen or touched. They read mountains like open books, followed river paths carved through stone, and traced ancient shorelines where fossils whispered of vanished worlds. But the ocean guarded its secrets in silence. It hid depths that sunlight never reached, and landscapes shaped in darkness. In earlier centuries, even the most skilled explorers could map only the surfaces of continents, not what was concealed beneath the waves. Because only a small fraction of Zealandia rose above sea level, it was easy for early geologists to treat it as a cluster of islands rather than the last summits of a continent. The islands carried the right kinds of rocks, the ancient granites and metamorphic stones that usually signal continental crust. Yet without context, they appeared isolated, like lonely survivors of a long lost past. No clear line connected them in the minds of researchers. The region seemed shattered, fractured into pieces too far apart to suggest a unified whole. The shape of the land beneath the ocean was still unknown. Soundings made with weighted ropes offered only the simplest of clues. These early measurements revealed that the sea around New Zealand became deep quite quickly, but they could not show the sweeping plateaus that stretched across the hidden continent. Without the tools to map the seafloor in fine detail, the underwater landscape remained an unpainted canvas, blank and mysterious. As the 20th century unfolded, technology improved, but progress was slow. Ships carrying echo sounders traced narrow lines across the ocean, creating thin strips of depth measurements. These lines helped sketch the outlines of undersea mountains and trenches, but the gaps between them were enormous. If a continent rested beneath those waters, its full form remained invisible between the scattered paths of surveying vessels. For generations, the idea that a continent might hide underwater felt improbable. Continents were thought to be firmly anchored above sea level, their buoyant crust resisting the weight of the oceans. If an area as large as Zealandia existed, many believed it would surely be visible. Yet the Earth does not always behave in ways that match our early expectations. Some continents can thin and sink over millions of years until only their highest ridges remain above the waves. The few islands that rose from Zealandia did not make this sinking obvious. Each one appeared independent, shaped by its own volcanic activity, uplift or erosion. Their geology hinted at a shared origin, but without detailed mapping of the ocean floor, these hints could not find their larger story. It was as if the ocean had scattered the pages of a book and hidden most of them where no early reader could reach. Modern methods arrived gradually. Satellite measurements began to detect changes in gravity across the surface of the planet, revealing subtle variations that hinted at thicker crust below certain regions of the sea. At the same time, new generations of sonar instruments allowed research vessels to sweep wide areas of the ocean with beams of sound, producing detailed maps of underwater landscapes. With each technological step, the ocean loosened its grip on a little more of its story. Patterns emerged, The seafloor around New Zealand rose gently into broad plateaus, unlike the steep volcanic ridges found elsewhere in the Pacific. These shapes suggested buoyant continental crust rather than the dense rock of the deep ocean. Magnetic signatures lined up across long distances, mirroring the patterns seen in known continents. Geologists began to suspect that the land beneath the ocean might not be a scattering of unrelated fragments, but something far larger and more coherent. Yet suspicion alone was not enough. Science trusts evidence, especially when a discovery challenges long held assumptions. It took years of gathering data, comparing results, and refining models before the full picture became clear. Until then, the idea of a hidden continent felt like a possibility waiting for its proof. By the time the 21st century arrived, the pieces had begun to fit. Satellite maps gave shape to the gravity anomalies. Seafloor surveys revealed the contours of vast underwater plateaus. Rock samples told stories of ancient origins that matched the geology of traditional continents. And slowly, certainty took form. What had once been treated as isolated islands grew into the peaks of a much larger realm, a region that met every scientific criterion for continental status. The revelation felt quiet and steady, the culmination of centuries of exploration and decades of advancing technology. It arrived not through one dramatic moment, but through countless small discoveries that together illuminated an entire world hidden beneath the waves. And so, in the year 2017, Zealandia stepped into scientific recognition, not newly formed, but newly understood. It had waited beneath the Pacific, patient in its silence, until human tools became precise enough to read the long submerged story written in its stones. As technology deepened its reach into the oceans, the surface of the sea no longer felt like a barrier. Bit by bit, sound waves traced the shapes of hidden worlds, peeling back the blue veil that had covered them for millions of years. The maps that formed from these echoes were called bathymetric maps, mosaics of light and shadow that revealed the sea floor with a clarity earlier generations could never have imagined. With every new survey, the Pacific grew less mysterious, and the outlines of something unexpected began to rise. When these maps were assembled across vast stretches of ocean, they displayed landscapes that had never touched sunlight. Long ridges curved beneath the waves, shaped like the spines of ancient mountains. Broad plateaus stretched outward like submerged plains. Deep basins formed valleys large enough to cradle entire cities if they had ever stood above water. These features were not scattered in the chaotic way that volcanic islands often form. Instead, they connected, gently and deliberately, as if they belonged to a single structure. Seen from above, the pattern became unmistakable. It was like looking at the skeleton of a continent, one whose flesh had dissolved into the sea, but whose bones still held their ancient form. The contours that appeared on the screens of research vessels suggested highlands and lowlands, regions of uplift and regions of collapse. There were scars where tectonic forces had stretched the crust, and smooth rises where lighter rocks still floated higher than the surrounding seafloor. It was not the raw geometry of oceanic ridges, nor the jagged fingerprints of volcanic arcs. It was something broader, older, and far more familiar. The scientists who studied these images already knew that Zealandia existed as fragments above the waves, shimmering in the sunlight of New Zealand and its neighboring islands. They had touched its rocks with their hands and studied their minerals under microscopes. Yet seeing its full form beneath the water was entirely different. The islands that seemed small and isolated on traditional maps now sat atop vast foundations. The mountains, the valleys, the long drowned plateaus, all aligned as parts of a much larger, unified world. There is a quiet strangeness in looking at a landmass you cannot walk upon. The bathymetric maps made it feel as though Zealandia lingered in two states at once. It was present, yet unreachable, visible in shape, yet hidden in substance. Some researchers described it as a ghost continent, a world that had not vanished entirely, but had slipped beyond the reach of human senses. The term did not imply haunting, only a gentle unreality, like seeing familiar forms through fog. This feeling came not from fear, but from perspective. Continents are usually points of certainty. They mark the places where civilizations rise, where mountains catch snow on their peaks, where forests root themselves in deep soil. To see a continent outlined in darkness beneath the Pacific, resting in a realm where pressure crushes and light never falls, was to encounter Earth's quiet reminder that the surface we know is only one layer of its story. The maps continued to improve. Ships traced denser grids across the water, filling in gaps until the mountains beneath the ocean appeared with striking detail. Ridges stretched for hundreds of miles. Sunken basins dropped gently like wide open palms. The plateaus appeared smooth from afar, yet up close revealed subtle folds that told of ancient forces pushing and pulling the crust in slow, relentless motion. In these features, scientists saw more than shapes. They saw history. They saw the remnants of rift zones where Zedinia had begun to separate from larger land masses long ago. They saw the uplift of ridges that once might have stood above sea level, catching rain and wind and sunlight. They saw valleys that could have carried rivers, and coastlines that might once have traced the edges of forests and meadows. It was as if the ocean had preserved the architecture of a lost world, holding it just out of reach, yet offering its outline generously to those who knew how to look. The strange beauty of these discoveries lay in their quiet certainty. There was no need for imagination to fill in the gaps. The maps revealed patterns that matched those seen on every known continent. Mountain ranges rose in long arcs, plateaus broadened where crust had thickened, basins marked areas where the land had sunk slowly over time. Nothing about these features belonged to oceanic crust. They bore the unmistakable signs of continental heritage. As this submerged landscape emerged from obscurity, it became clear that Zealandia had never truly been absent. It had lived in plain sight, hidden only by the shimmering surface of the Pacific. What earlier generations lacked in tools, modern science supplied with patience and precision. With each survey, the ghost became more solid, transforming from a whispered idea into a continent with measurable breadth and depth. The ocean had kept Zealandia quiet for millions of years, yet through these gentle maps of sound and light, it allowed the world to see it again. In that moment, the continent revealed itself not as something lost, but as something patiently waiting to be understood. As the shape of Zealandia grew clearer through the deep, patient work of mapping, another question quietly followed. What kind of world had existed on this continent before the sea reclaimed it? The answer did not come from the sweeping forms revealed by satellites or sonar. It arrived in smaller things, in the delicate traces left behind by landscapes that had long since passed into memory. These traces were carried upward from the seafloor in narrow cylinders of sediment, lifted by drilling ships that touched the hidden continent with careful hands. Each core sample rose from the darkness like a timeline pressed into stone. Layers of mud, silt, and sand settled gently into place over millions of years, holding fragments of environments that had once breathed air or flowed with water. Near the uppermost layers, the sediments told familiar stories of cold, deep oceans. But as researchers dug deeper into the cores, they began to find textures and grains that did not belong to the open sea. Some layers held sands that had been rounded and smoothed in ways that only flowing rivers can shape. The grains were too coarse, their surfaces too polished by tumbling journeys. These sands carried the rhythm of freshwater currents, not the still weight of the deep ocean. Their patterns hinted at channels that once carved their way across Zealandia's surface, weaving through valleys and plains that sunlight warmed. The rivers that left these traces had long since vanished, yet their presence lived on in the quiet language of the sediments. In other layers, researchers found tiny fragments of organic material preserved in pockets where water and minerals locked them away. These pieces were remnants of plants that never grew at sea. Their shapes were softened with age, but their origins were unmistakable. They came from leaves and stems that once reached toward the light, drawing life from soils that no longer exist above the waves. The remains did not belong to a single species or a narrow range of conditions. Instead, they suggested broad, thriving landscapes, shaped by weather and seasons, and fed by rich earth. Further studies uncovered pollen grains, small enough to drift on wind, yet strong enough to endure deep time. Under microscopes, they displayed intricate patterns, each one a signature of a plant that once grew on Zealandia. Some of the grains belonged to forests that flourished in warm, humid climates. Others came from subtropical trees that prefer mild temperatures and steady rainfall. Their presence painted a picture of a continent graced with lush greenery, where forests stretched across hills and lowlands, and where ecosystems rose and fell with the shifting ages. Alongside the plant remains were fossils of animals that lived far from the ocean. They were not abundant, since much of Zealandia's record lies buried beneath water that makes collection difficult. But the few that were recovered left little doubt. Some bones belonged to ancient reptiles that walked on land. Others came from birds whose ancestors once filled the skies above this lost continent. These fossils added weight to what the sediments already told. Zealandia had been a place of rivers and forests, not merely a fragment of ocean floor. The story deepened as researchers examined minerals that form only in soils exposed to air. These minerals were shaped by cycles of wet and dry seasons and by interactions between rock and vegetation. Their chemistry held memories of sunlight, rainwater, and organic decay. To find them beneath kilometers of ocean water was to uncover proof of an ancient landscape that had not always known the quiet darkness of the sea. Some cores even revealed layers of charcoal, tiny black flecks that spoke of fire. Fire does not burn beneath the ocean. It flickers through grasslands and forests, sweeping across hills when lightning strikes or when dry seasons linger. The charcoal grains were small, yet they carried the unmistakable signature of vegetation touched by flame. These traces suggested that Zealandia once experienced the natural cycles that shape life on land, with fires clearing old growth and making way for new. Piece by piece, the evidence formed a tapestry. The sediments that showed riverbeds spoke of flowing water. The plant remains whispered of forests rich with life. The pollen revealed climates mild and welcoming. The animal fossils added movement to the stillness of the stones. Together, they reconstructed a world long submerged, one that had known the warmth of sunlight and the breath of wind, a world that existed in full before the ocean slowly rose and claimed it. It is a gentle truth that continents can change their height over ages. Some are lifted by the slow push of tectonic forces. Others stretch so thin that their weight brings them downward. Zealandia belonged to the latter, yet even as it settled beneath the Pacific, it carried the memories of its former life within its rocks and soils. These memories are what scientists now read carefully and patiently through the evidence preserved in the deep. And with every core sample lifted from the seafloor, a little more of Zealandia's lost landscape returns to light, offering a quiet glimpse into a continent that once rose proudly into the sky. Long before the sea spread itself across Zealandia, long before its forests slipped beneath rising waters and its mountains sank into blue silence, the continent lived a life on the surface of the world. The clues that emerged from sediments and fossils hinted not only at the landscapes that once flourished there, but at the living tapestry that moved across them. When scientists began to imagine Zealandia as it had been, their thoughts shifted from the stones themselves to the warmth of the world that once surrounded them. The climate of ancient Zealandia drifted through ages of change, yet much of its story carried a gentle, temperate rhythm. Many of the pollen grains lifted from the seafloor belong to plants that thrive in mild environments, where winters soften quickly into spring and summers settle into steady warmth. Other grains bore the signatures of forests found today in subtropical regions, where humidity rises like a soft breath from the canopy and rain falls in long, nourishing cycles. From these patterns, a picture formed of a continent graced with broad forests and rolling green lowlands. In some eras, the climate likely resembled modern New Zealand, with cool highlands and lush coastal valleys where ferns and ancient trees grew in layered abundance. In other periods, warmer currents of global climate may have encouraged more subtropical growth, filling Zealandia with palms, cycads, and towering trees related to those that now cling to scattered islands across the Pacific. The air would have carried the scent of rich soil, and the forests might have moved gently in winds that crossed thousands of miles of open ocean. Where rivers once wound across this landscape, animals would have followed their paths, leaving footprints that only time could erase. Although the fossil record of Zealandia is thin, partly because so much of it lies beneath cold water and heavy pressure, the traces that do appear invite quiet imagination. The few bones and impressions found hint at creatures that lived in ecosystems shaped by long isolation. This isolation, a familiar artist in Earth's history, tends to sculpt life in unusual and remarkable ways. Australia offers one example of how separation from other landmasses can create a cradle for unique evolution. Marsupials grew into giant kangaroos and ancient diprotodons. Warm rains fed forests where strange birds developed powerful legs instead of strong wings. Farther south, New Zealand itself produced birds that pushed the limits of size and form. The towering moa, the swift and sharp-beaked Haast's eagle, and countless species of flightless birds all arose in the quiet solitude of land unconnected to any continental neighbors. Zealandia, much larger than modern New Zealand, had even more room for such evolutionary experiments. Its mountain ranges would have created pockets of varied climate, from cool upland plateaus to warm valleys where subtropical plants grew thickly. Its coasts would have stretched for thousands of miles, shaping ecosystems rich with marine life and offering shelter to birds that thrived at the boundary between land and sea. While direct evidence remains rare, scientists believe that Zealandia may once have hosted giant birds similar to the ancestors of the moa, long before those species evolved in the form we know today. Ancient reptiles might have walked the forest floors, some related to lineages that later found refuge only in New Zealand's remote corners. Small mammals, if they lived there at all, may have followed evolutionary paths now lost to the ocean. In isolation, evolution does not hurry. It drifts, carried by time and chance, shaping creatures uniquely adapted to the world around them. The subtropical warmth of certain eras could have supported forests dense with cycads, conifers, and ferns that grew in spiraling patterns along riverbanks and coastal flats. Warm winds would have moved through canopies, alive with insects that evolved without the pressures found on more connected continents. Birds may have become more dominant through the ages, taking advantage of fewer predators. Their calls would have filled the forests with melodies now long forgotten. Along the shores, marine creatures may have crossed the boundary between land and sea in curious ways. Seabirds, could have nested on cliffs that rose above foaming waves. Reptiles adapted to both water and land might have lived in sheltered inlets. The world would have felt self contained, shaped less by competition with distant regions and more by the quiet unfolding of time within an island continent. As Zealandia continued its slow transformation, thinning and settling as tectonic forces shifted around it, its ecosystems would have followed the changing land. Some forests may have retreated to higher ground as sea levels crept upward. River pathways would have shifted, carving new routes through valleys and leaving old ones behind. Life adapted in step with the land, each generation responding gently to the changes that touched their world. Eventually, as the continent sank further, the living tapestry thinned. Species that once roamed broadly across its surface moved to shrinking islands or vanished altogether. The forests dwindled, replaced by the rising waters that would one day conceal the entire continent except for its highest peaks. Yet the memory of that world remains in the fragments scientists lift from the deep, in the warmth locked within fossil pollen, in the delicate impressions of ancient plants, in the bones of creatures that walked the land when the sky stretched open above them. These traces speak softly of a time when Zealandia stood in sunlight, alive with its own unique rhythms of climate, life, and evolution shaped in peaceful isolation. The world that once lived there is gone, yet through careful study, it still breathes faintly beneath the surface of the Pacific, a quiet story held in the stones of a continent that sank but did not disappear from Earth's deeper memory. As scientists continued to explore Zealandia, the soft clues of forests and rivers were only the beginning. Beneath those quiet reminders of life lay another story, one carved deep into the bones of the continent itself. When geologists speak of a vanished world, they often turn not to fossils or pollen, but to the patterns etched into the crust. These patterns reveal the forces that once shaped the land. They show how the earth breathed, shifted, and eventually sank. In this sense, Zealandia became a kind of geological crime scene, a place where every fracture, every fault, and every subtle line in the rock recorded a chapter of its long disappearance. To understand these signs, researchers first began to trace the structure of Zealandia's crust with great precision. They studied maps that showed not only the shape of the seafloor, but the hidden lines of weakness beneath it. These lines, called faults, crisscrossed the continent like scars left from ages of strain. Some faults stretched for hundreds of miles. Others sat quietly beneath younger sediments, still visible to those who knew how to read the patterns. These faults did not form at random. They reflected the immense stresses that pulled Zealandia apart as it separated from larger landmasses millions of years earlier. The crust fractured in long ribbons, each one showing where rock had torn under the slow, unrelenting pressure of shifting plates. Over time, these fractures widened. Parts of the crust moved away from each other or slid past each other. Some blocks tilted gently, while others collapsed into deeper basins. Together, the faults shaped a landscape that became thinner and more vulnerable with every passing age. When researchers mapped these fractures using seismic waves and magnetic surveys, they began to notice something remarkable. The faults aligned in patterns that resembled the stretched fabric of a cloth pulled too far. Long parallel lines marked regions where the crust had thinned. Some areas bore signs of dramatic stretching, where rock layers had been drawn out like taffy warmed by the planet's internal heat. These stretched regions revealed why Zealandia sank. A continent with thin crust cannot float as high as one with thick roots. As Zealandia weakened, it slowly settled downward, letting the ocean rise over it. The evidence of this stretching could be seen in the lineations that crossed the seafloor. These were subtle ridges and grooves, running in directions that mirrored the movement of ancient tectonic forces. Some lineations formed where blocks of crust tilted during rifting. Others marked places where volcanic activity once pushed upward, only to quiet as the land slipped beneath the waves. Each line told a piece of the story, like the faint handwriting of time itself. Geologists approached this landscape like detectives. They took each fault, each lineation, each uplifted ridge, and placed it within a broader map of Earth's movements. They compared Zealandia's fractures to those of other continents that had broken apart from ancient supercontinents. In these comparisons, recognizable patterns emerged. The shapes of the faults echoed the breakup of Gondwana, the vast landmass that once joined parts of Antarctica, Australia, Africa, South America, and the Indian subcontinent. Zealandia had drifted away slowly from this ancient world, and the fractures held the memory of that long journey. To reconstruct the vanished continent, scientists used computer models that simulate the slow dance of tectonic plates. They fed data into these models, allowing the crust to move backward through time. The stretched land folded inward, the faults closed, the basins lifted. Over millions of virtual years, Zealandia rose toward the surface, regaining the shape it once held when forests still stood across its plains. These models did not restore the living world that once existed there, but they offered a glimpse of its geographical past. They revealed what parts of the continent once lay higher, which regions formed mountains, and which valleys carried rivers from one coast to another. Other reconstructions came from studying the minerals found in rocks brought up from the seafloor. Some minerals formed under high heat and pressure, deep in the crust. Others formed near the surface, shaped by weather, erosion, and soil. By comparing their ages and structures, scientists could determine how quickly the crust rose or fell in different eras. In some places, the rocks showed signs of sudden change, where fault lines slipped and entire regions shifted dramatically. In others, the change was slow and gentle, a long sinking that continued for millions of years. Taken together, these patterns created a detailed portrait of a continent caught between forces greater than itself. Zealandia had not vanished through a single catastrophic event. Instead, its disappearance unfolded through a long chain of geological steps, each recorded in the orientation of a fault or the angle of a tilted rock layer. The crust told a story of tension, stretching, and eventual collapse into the embrace of the sea. Standing back from the data, geologists could see the continent as it once was, not in full color or living motion, but in the sturdy outlines left behind by stone. The fractures and lineations became pathways into the past, allowing the shape of Zealandia to emerge from the deep once more. And through this quiet reconstruction, the hidden continent revealed another of its secrets. Even in silence, even beneath the weight of the Pacific, it continued to speak through the patterns carved into its ancient crust, telling the long and patient story of how a continent slowly faded beneath the sea. By the time Zealandia's landscapes had taken shape and its forests breathed gently beneath shifting skies, deeper changes were already unfolding beneath its foundations. These changes were not sudden or violent. They moved with the patience of geological time, whispering through the crust long before any river carved a valley or any tree rooted itself in the soil. To understand how the continent began its slow descent beneath the Pacific, we must follow these quiet motions into the deep mantle where heat and pressure guide the rise and fall of entire worlds. Zealandia once belonged to a much larger land, the ancient supercontinent Gondwana. When Gondwana began to pull apart, the forces that tore at its edges did more than reshape coastlines. They stretched the crust itself, thinning it across broad regions. Imagine a sheet of warm dough pulled steadily in opposite directions. Its center would become thin and delicate while its edges drifted away. The crust beneath Zealandia behaved in much the same way, drawn outward as Australia, Antarctica, and other fragments drifted from their ancient union. This thinning did not make the land vanish at once. Instead, it weakened the buoyancy that kept the continent afloat. Continental crust usually rides higher than oceanic crust because it is lighter and thicker. But a thinned continent loses some of that natural lift, much like a raft that has been worn soft in the middle. Zealandia's crust grew slender in many regions, stretched until its strength diminished. Even while mountains rose above it and forests grew across its valleys, the continent was already carrying the seeds of its eventual sinking. Below this thinning crust, the mantle played its own quiet part. The mantle is not molten, as old stories sometimes imagine, but behaves like a slow-moving river of solid rock under immense heat. Some regions of the mantle rise slightly warmer and less dense, lifting the crust above them. Others cool and grow heavier, pulling the crust downward. During Zealandia's early separation from Gondwana, warmer mantle supported parts of the land, giving them a gentle buoyancy that helped keep the continent near the surface. Over time, however, the heat beneath Zealandia changed. As tectonic plates shifted, the continent drifted away from the mantle plumes and hot zones that once supported it. With less heat rising beneath it, the crust cooled slowly. Cooling causes the mantle to contract slightly. As it contracts, it becomes denser, and this increased density places more weight on the crust above. Zealandia, already thinned by the stretching that marked its birth as an independent landmass, began to settle downward. This settling was subtle, almost imperceptible on human timescales, but across tens of millions of years, the effect grew profound. Valleys lowered, coastal plains dipped closer to the sea. Regions that once stood comfortably above sea level began to edge toward the water's reach. Rivers carved their paths, unaware of the deeper movement beneath them. Forests grew across lands whose foundations were sinking grain by grain into geological time. The slow descent was not uniform. Some parts of Zealandia remained thicker and more resistant to sinking. These became the regions that still peak above the waves today, forming the rugged islands of New Zealand and scattered ridges that break the ocean surface. Other areas, stretched thin and cooled by the changing mantle, dipped more quickly. They formed broad, submerged plateaus and basins that now lie under thousands of meters of water. As the mantle cooled beneath Zealandia, its weight continued to increase, tugging gently at the continent's roots. This gentle pull is known as subsidence. It is a natural process that shapes many continental margins, yet on Zealandia it played a larger role because of the crust's unusual thinness. The land did not collapse abruptly. Instead, it sank in stages, each stage lasting millions of years. Seas flooded lowlands, forested hills became islands. Islands shrank until only their highest peaks remained above water. The rest slipped into the quiet, steady deep. Throughout this transition, the continent's identity remained unchanged. Even as it lowered beneath the surface, its crust preserved the characteristics of continental material. Its rocks held the memory of mountains long eroded. Its faults recorded the strain of earlier ages. Its submerged plains still carried the shapes of the landscapes that once stretched under open skies. The story of Zealandia's sinking is not one of sudden catastrophe. It is the story of a continent carried slowly downward by shifts in heat and weight, a story of land stretched thin by the breakup of an ancient supercontinent, a story of mantle currents rising and falling in patterns as old as the planet itself. These forces acted with a quiet persistence, guiding the continent into deeper water as millions of years passed. Yet even in its sinking, Zealandia remained whole. Its geological fabric stayed connected. Its basins, ridges, and ancient mountain roots continued to move as one. The continent simply slipped below the surface, not lost, but hidden, held gently by the surrounding sea. And so, the long descent began, carried by the deep rhythms of Earth, shaping the silent transformation of a continent that once stood in sunlight and now rests beneath the vast Pacific sky. By the time Zealandia began its slow descent beneath the ocean, its fate had already been written deep within the quiet fabric of its crust. The continent carried a weakness that set it apart from the great land masses of the world. This fragility was not obvious on the surface. Forests had grown across its plains, mountains had lifted against the sky, rivers had shaped the valleys. To the life that walked upon it, the land felt steady and whole. Yet from a geological perspective, Zealandia was delicate from the moment it separated from Gondwana. Most continents possess crust that reaches impressive thicknesses, often extending far downward in sturdy, buoyant layers. This thickness allows them to float high on the mantle, like large rafts that glide atop deeper currents of rock. Zealandia, however, formed with only about half the thickness of its continental neighbors. It was continental crust, ancient and distinct from the floors of the oceans, yet it lacked the solid footing that keeps other continents confidently above sea level. Its roots were simply not deep enough to give it lasting buoyancy. This thinness shaped every part of Zealandia's story. When Gondwana fractured and its pieces drifted apart, the stretching forces that acted on Zealandia had a greater effect than they would have on a thicker continent. The crust responded like a leaf pulled gently from its stem. It lengthened under tension, becoming even more slender as it moved. Regions that had once been stable began to stretch into broad, shallow basins. Other regions tilted or sagged, unable to resist the forces drawing them apart. The danger of being stretched too thin is easy to imagine. A strip of cloth pulled steadily at its edges begins to lose its structure. Its threads separate, its weave loosens. A surface that once felt strong becomes delicate, then fragile. Zealandia's crust experienced something similar. The more it stretched, the more it thinned. The more it thinned, the more it sagged under its own weight, and each subtle change brought the land a little closer to the sea. This process unfolded slowly, almost lazily, across vast stretches of time, yet the physics behind it were unyielding. The deeper layers of Earth support continents through buoyancy, much like water supports a floating object. Thicker crust floats higher because it is lighter relative to the material below it. Thinner crust sinks lower. Zealandia's crust, already slender, lost more of its support with every episode of stretching and cooling. Even without dramatic external forces, the continent began drifting downward through a process called long-term subsidence, a gentle yet persistent sinking that touched every corner of the land. As Zealandia settled deeper, the balance between land and sea quietly shifted. Lowlands became vulnerable to flooding. River valleys that once drained into the ocean found themselves slowly overwhelmed by rising waters. Coastal plains turned to marshes, then shallow seas. Eventually, even higher regions began dipping below sea level as the continent continued its drawn-out descent. The thinning crust also made Zealandia more sensitive to changes in mantle temperature. When the mantle beneath a continent is warm, it lifts that continent slightly, offering gentle support. When the mantle cools, it contracts and grows denser, pulling downward with increased force. Because Zealandia's crust was so thin, it responded to these changes much more dramatically than a thicker continent would. A small decrease in mantle heat caused a noticeable drop. Over millions of years, this sensitivity compounded, accelerating the continent's gradual submergence. There was another consequence hidden in this fragility. When landmasses break apart, volcanic and tectonic activity often accompanies their early stages, offering bursts of uplift or new mountain building. These forces can temporarily raise regions of crust, giving them fresh life above sea level. Zealandia did experience such activity, but its crust was too thin to sustain much uplift. Mountains rose, but not enough to counter the broader sinking. Ridges formed, but they were easily worn down. The continent simply lacked the deep structural strength needed to maintain high elevations through cycles of geological change. In the end, this fragility doomed Zealandia's ability to remain above the water. Even though it carried all the characteristics of a true continent, its physical makeup worked constantly against it. The moment it separated from Gondwana, it began a long journey toward the Pacific floor, not in dramatic steps, but in a slow, continuous descent guided by physics and time. Some parts resisted a little longer. The areas where the crust remained slightly thicker rose into shapes that would someday become the peaks of modern New Zealand. But these surviving fragments were the exception. Most of the continent sank as its thin crust lost buoyancy, surrendering before the steady pull of gravity and the cooling mantle beneath. Today, Zealandia rests mostly underwater, a vast continent shaped by fragility rather than force. Its thin crust wrote its destiny, guiding it downward inch by inch across millions of years. Yet even beneath the Pacific, that fragility holds a quiet beauty. It made Zealandia a continent unlike any other, a place where ancient landscapes still linger in darkness, carried by a structure that could not remain in sunlight, but that continues to tell its story through the quiet language of stone. Before Zealandia began its long descent into the quiet blue of the Pacific, it experienced a very different kind of journey, one shaped by the slow parting of continents that had once been joined in a vast and ancient whole. Gondwana, the supercontinent that held together many of the southern lands we know today, stretched across high latitudes like a quilt of forests, mountains, and deserts woven together by deep time. Zealandia was one piece of this immense patchwork, resting between what would one day become Antarctica and Australia. The beginning of Zealandia's separation can be traced to a time when the Earth's interior shifted its patterns of heat and movement. Mantle currents swirled beneath Gondwana, rising in plumes that gently lifted regions of crust and weakened the bonds that held the supercontinent together. This weakening did not split the land immediately. It simply set the stage, thinning certain regions ever so slightly, preparing them for the gradual rifting that would unfold over millions of years. Rifting is a slow, gentle pulling apart of the crust, a process that begins far below the surface. Deep fractures form first, often invisible from above. These fractures widen as molten rock from the mantle wells upward, not in violent bursts, but in steady, patient flows. The heat softens the crust, the stretching widens it. Over long stretches of time, the land begins to part, almost like taffy warming in the sun. It lengthens, it thins, it bends, and eventually the cracks become wide enough that water finds its way in. For Zealandia, the rifting began when Gondwana started to split into pieces that would eventually drift across the planet. Australia began to pull northward. Antarctica moved gradually south. Between them, Zealandia felt the tension like a seam being tugged from both ends. The crust beneath it fractured, forming long zones of weakness that stretched across what would become the submerged continent. These fractures widened into rift valleys. In some places, molten rock seeped upward, cooling into new layers of crust that pushed the edges of the land further apart. As these valleys deepened, they filled with water, forming early seas that marked the growing divide between the separating continents. Zealandia found itself caught in the middle of this slow unfolding. It was not pulled away suddenly. It drifted, inch by inch, with the steadiness of continental motion that only looks still because our lives pass so quickly. As Zealandia drifted away from Australia and Antarctica, its own crust responded to the strain. Already thinner than most continents, it stretched even more under the continued pressure. This added tension weakened the land significantly. What had once been a sturdy connection between the three landmasses became a thinning bridge, and finally, a narrow strand. Eventually, that strand broke altogether, leaving Zealandia to drift as its own independent continent. The separation affected the land in several ways. Where the crust was stretched, it became like a fabric pulled too far, losing its thickness and strength. Some regions sagged immediately. Others held their shape for a time but remained vulnerable to future changes. The newly formed ocean basins created by the rifting pressed downward on the surrounding crust, adding weight that further encouraged subsidence. The mantle beneath the stretching land cooled more rapidly, removing any remaining buoyant support that might have kept Zealandia high above the waves. The drifting itself shaped the climate above the land. As Zealandia moved farther from the colder embrace of Antarctica, it entered milder latitudes. Forests changed, rivers carved new paths. Species evolved in isolation, shaping ecosystems that grew ever more distinct. Yet beneath these changes, the continent continued to thin and stretch. The rifting had set a slow and irreversible direction for its fate. In certain regions, volcanic activity accompanied the separation. These bursts of molten rock created highlands that would later become some of the sturdiest remnants of Zealandia's original surface. But these volcanoes could not counteract the larger forces. They were like small beads of solder placed upon a bending branch. They strengthened small pieces, but they could not protect the whole. As Zealandia drifted farther into the Pacific, water widened the space between it and its former neighbors. The oceans surrounded it fully. The continent began to behave as a separate geological body, responding only to the forces acting upon it. Those forces continued to stretch, cool, and thin its crust. Gondwana had gifted Zealandia its identity. The separation, however, shaped its destiny. With each passing million years, Zealandia sank a little more. Not quickly, not dramatically, but with the steady grace of a continent guided toward the sea by the physics of its own structure. The rifting that had once set it free from Gondwana also set it on a path toward submergence. Its thin crust, once part of a massive and buoyant supercontinent, could not keep it aloft alone. In time, only the tallest mountains of Zealandia would stand above the water, forming the islands we know today. The rest would slide beneath the Pacific, carrying with it the memories of the forests, rivers, and ancient life that once flourished upon its surface. And so, Zealandia's break from Gondwana was both a beginning and a quiet ending, a slow movement away from an ancient whole, a step toward becoming a continent hidden beneath the sea, shaped by forces too patient for human eyes, yet written clearly in the stone beneath the waves. Once Zealandia had drifted free from Gondwana, its path was no longer shaped by the gentle tug of separation alone. The continent entered a far more complex part of Earth's slow choreography, a realm where deep forces converged to guide its fate. Beneath the quiet surface of the Pacific, the mantle shifted in long, deliberate currents. Tectonic plates pushed and pulled at one another in patterns that unfolded across millions of years. And through all of it, Zealandia moved as a passenger carried by forces larger than itself. Far below the crust, the mantle behaves like a river of stone. It does not flow quickly, but it moves with the persistence of tides, shaped by heat rising from Earth's core and by the cooling of the surface above. These mantle currents created zones where material rose upward, lifting the crust slightly, and zones where material sank, dragging the crust downward with it. As Zealandia drifted away from the warmer mantle beneath Gondwana, it eventually passed over regions where the mantle descended more heavily. This descent formed a kind of geological undertow. The crust above these sinking regions lost support and slowly sank with them, carried downward inch by inch. For Zealandia, this shift in mantle flow came at a fragile time. Its crust had already thinned during the long rifting process. Without the depth and strength of other continents, it responded more dramatically when mantle currents changed beneath it. Where the mantle dipped, Zealandia sagged. Where it cooled, the crust settled. The continent's buoyancy weakened further, not through any single dramatic event, but through the quiet persistence of forces acting on it from below. While the mantle pulled gently downward, another force shaped the continent from the side. Along the edges of Zealandia, the Pacific Plate pressed against it. The Pacific Plate is enormous, one of the most active tectonic plates on Earth, moving steadily across the planet's surface. In some regions, it slides beneath neighboring plates in a process called subduction. In others, it compresses their edges, bending and deforming them slowly over time. As Zealandia drifted into the path of the Pacific Plate, it encountered both of these effects. In the west, the plate system forced Zealandia downward as the Pacific Plate slid beneath it. This motion created deep subduction zones that pulled the crust into steeper angles. These zones are like long, hidden wedges beneath the ocean floor. As one plate sinks beneath another, the overlying plate flexes downward. This flexing can drag entire regions of crust with it, guiding them into deeper water. The more the Pacific Plate pressed and shifted, the more Zealandia's edges buckled under the strain. Certain regions experienced intense compression, folding and tilting as the plates collided in slow motion. These compressive forces squeezed the crust, making weaker parts even more vulnerable. In some places, mountains rose as rock was pushed upward, but elsewhere, the pressure drove the crust downward, adding to the subsidence already caused by mantle flow. The Pacific Plate did not act alone. Around Zealandia, a network of smaller plates and microplates moved in their own subtle patterns, creating a complicated web of motions that shaped the sinking land. Some pressed upward against Zealandia's edges, while others slid past it. Together, these movements created zones of stretching, zones of compression, and zones where the crust was pushed in opposite directions at once. All of these combined forces placed immense strain on a continent that was already thin and delicate. One of the most important consequences of these interactions was the way they influenced the basins forming around Zealandia. As the Pacific Plate interacted with the continent, new basins opened or deepened along its edges. These basins formed depressions that filled with ocean water. As the depressions grew, the weight of the water pressed downward on the crust below, adding an extra force that encouraged further sinking. At the same time, parts of Zealandia were pulled laterally by the shifting plates, stretched in directions that aligned with the motion of the Pacific Plate. This stretching thinned the crust even more, reducing its buoyancy. Every change added to the cumulative downward pull. Even regions far from the plate boundaries, felt the effects. The deep mantle currents beneath the Pacific, the slow subduction of the plate, and the gradual cooling of the crust all combined to create a long-term downward trend. Zealandia hovered between the strength of a continent and the vulnerability of oceanic crust, and in that delicate balance, the surrounding forces pushed it steadily toward the sea. As the continent continued to sink, the final stages of its transformation unfolded. Valleys disappeared beneath rising water, plains turned into shelves, mountain ranges softened under the weight of surrounding seas, leaving only their highest peaks visible. Everything that had once stood tall was now shaped by the deep forces beneath it. The Pacific Plate continued its slow march, reshaping the boundaries of the region in patterns that still evolve today. Subduction uplifted some areas, while dragging others under. Modern New Zealand, for example, rises in part because of these same forces, lifted by the tension between plates, even as the rest of Zealandia remains submerged. In these deep and patient shifts, Zealandia's fate became clear, not lost in a sudden catastrophe, but carried downward by the combined motions of mantle and plate. It sank not because it failed as a continent, but because the forces around it changed the stage upon which it existed. And so, beneath the vast Pacific, Zealandia rests, shaped by the gentle yet powerful movements of Earth's interior, a reminder that even continents live on a world that is always in motion, always evolving, always quietly rewriting itself through time. By the time Zealandia had thinned and drifted and been tugged downward by the quiet forces beneath and around it, the continent stood in a delicate balance between air and sea. Much of its surface had already dipped below the waves. Valleys surrendered first, plains followed. Forests retreated uphill as the land beneath them gradually sank. Yet even with all this change, Zealandia was not entirely claimed by the ocean. For a time, broad regions still rose above sea level, forming scattered plateaus and long ridges that caught wind and sunlight. Rivers still flowed, ecosystems still adapted, life lingered across the higher ground. Then the climate shifted. Earth has always moved between warm and cool ages, guided by the planet's orbit, the tilt of its axis, volcanic patterns, and other slow rhythms of deep time. During global warm periods, ice stored in glaciers melts back into the oceans. As the ice retreats, sea levels rise. These rises can be modest on human scales, measured in meters, but across millions of years, through repeated warm phases, the cumulative changes are profound. Coastlines migrate, lowlands submerge, archipelagos shrink, ancient connections between continents vanish beneath the rising water. For Zealandia, already weakened and low-lying, each warm period pushed the sea further across its surface. The coastlines that once traced sweeping arcs around forested hills crept inward, swallowing deltas and wetlands. Land bridges that had connected regions of the continent disappeared one by one, cutting off animal migrations and isolating populations on shrinking islands of high ground. Species that once roamed widely were gradually confined to smaller and more fragmented habitats. This loss of land did not happen suddenly. It was a quiet retreat, felt only by the creatures that depended on the narrowing spaces. Birds took to the skies as forests shrank beneath them. Reptiles followed the rising slopes until there was nowhere left to go. Over time, entire ecosystems were pushed upward, compressing into the last remaining pockets of habitable land. These remnants formed scattered highlands across the continent. In some areas, ranges of ancient mountains held firm for a while, standing above the rising waters, like fingers reaching from a sinking hand. In other regions, solitary peaks remained as lonely watchtowers above a spreading inland sea. Each warm period trimmed these highlands further. Each cycle pushed the waterline a little higher until the surviving land rose only in narrow belts and isolated islands. As Zealandia continued to settle downward, the sea level rises became even more powerful in shaping its final form. What had once been gentle continental slopes became submerged shelves. Ridges that had carried rivers turned into underwater valleys. The last low plateaus slipped beneath shallow seas, leaving only the tallest ridges exposed to air. By this stage, the continent had entered its final transformation. Most of what once existed above water had already become part of the ocean floor. The vast forests, the ancient plains, the landscapes shaped by millions of years of evolution, all now rested beneath layers of silt and cold, dark water. Only the highest mountains remained above the waves, and even these stood isolated, no longer connected by any land. These peaks are what we now call New Zealand. They are the spine of a continent long submerged, the last fragments of a world that once stretched across a region larger than India. Their summits still rise sharply into the air, shaped by wind, rain, and tectonic uplift that continues even now. Snow crowns their ridges, rivers flow through their valleys. Despite their rugged beauty, they are only the smallest surviving fraction of Zealandia's original mass. In the time before the final drowning, these mountains would have been part of vast ranges spanning hundreds of miles. Now they stand alone, separated from one another by deep ocean that once lay across fertile land. Their cliffs hold clues to the world that disappeared beneath them, clues preserved in rock layers that formed when Zealandia still lived fully in sunlight. As the ocean completed its slow claim over the continent, the final pieces of land slipped below water in stages. Some areas sank as part of the long tectonic sag that had begun millions of years earlier. Others were drowned by sea level rises, driven by warm climatic cycles. Together, these forces shaped a world that gradually but inexorably faded from the surface. Yet, Zealandia did not vanish entirely. Its submerged plateaus still stretch beneath the Pacific, forming landscapes of mountains, basins, and ridges that mirror those of other continents. Its crust remains continental in character, carrying the mineral signatures of ancient origins. Though hidden, it endures. The drowning of Zealandia was not a dramatic collapse. It was a long, graceful surrender to the shifting balance of Earth's interior and surface. Ocean, climate, and tectonic movement worked together in a slow weave that lowered the land piece by piece, leaving only the highest mountains to mark where a continent once stood. Those mountains, now forming the heart of New Zealand, rise as reminders of the world beneath the waves, holding the last breath of a continent that settled quietly into the sea. When Zealandia finally slipped beneath the sea, its landscapes did not vanish. They merely changed realms, leaving the world of sunlight for the quiet blue beneath. There, in the stillness of the deep Pacific, the continent's mountains, plateaus, and ancient arcs continued to exist, untouched by wind, yet shaped slowly by currents and time. As scientists mapped these submerged forms with careful instruments, the seafloor revealed a world that felt strangely familiar, as if a vast, ghostly continent were resting just out of sight. The first hints came from the broad sweeps of sonar tracing the ocean floor. The returning echoes carried more than simple depth readings. They revealed shapes. Long ridges rose from the deep, curving with the grace of mountain ranges found on large continents. Some stretched for hundreds of miles, their profiles sharp against the surrounding basins. Though they had not seen the sky for millions of years, these ridges resembled mountain belts built during a time when Zealandia still stood above the waves. Scientists began to refer to them as underwater Alps, a name that captured both their size and their quiet grandeur. These drowned mountains retained many features of their surface ancestors. Some had steep faces that once may have formed towering cliffs. Others showed gentler slopes, where forests might have clung to the earth and where rivers could have woven their patient paths. The tallest of these ranges rose toward the surface, though none reached close enough to break through. Instead, they lingered in the twilight zone, illuminated only by the faintest traces of filtered light. These high points were reminders of how much of the continent still exists beneath the sea, hidden yet elegantly preserved. Beyond the mountains lay broad sunken plateaus that told their own stories. These plateaus were different from the jagged forms associated with volcanoes. They spread out in sweeping expanses, their surfaces smooth and wide, much like the great continental interiors found on land. Some were large enough to have supported ecosystems stretching for hundreds of miles. If Zealandia had remained above water, these plateaus might have held plains, grasslands, and dense forests shaped by shifting climates. Now they sleep beneath cold currents and drifting marine snow. Their edges dip into deeper basins where sediments gather like soft blankets. The plateaus rise gently above the basins, creating contrasts reminiscent of mesas and uplands seen across other continents. Even submerged, these features hold the unmistakable signature of continental crust, and their scale rivals that of large land masses still visible today. Interwoven with these plateaus are long volcanic arcs that mark regions where Earth's interior once rose upward to form chains of fire. These arcs stretch across Zealandia in curved lines, mirroring the patterns seen along active continental margins elsewhere on the planet. When Zealandia was still above sea level, these volcanic arcs may have produced peaks that shaped weather patterns and defined local landscapes. Some eruptions would have sent ash drifting across wide valleys, nourishing soils that supported ancient forests. Others would have built mountains that stood as landmarks for countless generations of animals that roamed the continent. Today, only the bases of those volcanoes remain above the deep sea floor, softened by time. Their once fiery summits have been worn down or submerged entirely. Yet the arcs themselves are still clear, tracing paths that help scientists understand how tectonic forces moved through the region. They reveal how Zealandia's crust interacted with neighboring plates, how heat rose beneath it, and how the continent once pulsed with volcanic activity. Taken together, these mountain ranges, plateaus, and arcs form a landscape that would feel at home on any large continent. They possess the complexity and scale of features seen in places like Asia, North America, or Africa. They include long ridges that resemble the Appalachians, broad plateaus as vast as interior Australia, and volcanic chains whose shapes echo those in South America or Japan. And yet all of this lies beneath the Pacific, hidden from casual view. The underwater Alps do not catch snowfall. The submerged plateaus do not warm under morning sun. The volcanic arcs do not glow with eruption. Instead, they rest in a world where pressure grows with every meter of depth and where light fades into near silence. Still, their presence is unmistakable. They are the bones of a continent that never lost its identity, even as it sank. In their shapes, scientists can read the history of Zealandia's rise and fall. They can trace the ancient forces that built the continent, the long rifting that stretched it thin, and the gentle downward pull that submerged it. These drowned landscapes offer a quiet reminder that Earth's continents are more than what we see on maps. Much of their stories lie in places we rarely imagine, in the deep spaces beneath the waves where mountain ranges still stand, plateaus still stretch wide, and volcanic arcs still mark the echoes of ancient fire. Zealandia may be hidden, but its form remains whole, a vast submerged world waiting patiently beneath the ocean, preserving the enduring outlines of a continent that once touched the sky. As scientists continued to explore the quiet world resting beneath the Pacific, they began to find clues far stranger than mountain ranges or plateaus. These clues did not rise in sweeping shapes or grand structures. Instead, they existed in tiny fragments, grains of ancient life preserved in sediments that had been buried for millions of years. Each piece carried a whisper from a time when Zealandia stood in sunlight, and together they revealed stories that seemed impossible in the deep ocean where they now lay. The first hints appeared in long cores of sediment lifted from the seafloor. These cores rose from the darkness in slender cylinders, each one preserving layer upon layer of time. When the samples were split open, they revealed fine bands of mud and sand that settled gently across the continent after it sank. Most layers told the quiet tale of open water. Tiny shells from deep ocean organisms rested in patterned drifts. Particles of marine snow, formed from the slow rain of organic material, created soft streaks of pale sediment. Then something unexpected appeared. Mixed among these deep ocean layers were grains of pollen, fragile yet perfectly preserved. Under the microscope, each grain showed delicate patterns, the unique signatures of plants that once flourished on land. Some belonged to trees that grow in warm, humid climates. Others came from species that prefer mild conditions and gentle seasonal shifts. Their presence far beneath the ocean puzzled researchers at first. Pollen cannot form in open water. It cannot drift for long below the sunlit zone. It comes only from landscapes that breathe air, from forests that sway in wind, from flowers that open to daylight. The explanation lived in the layers of time. These grains had settled into the sediments during the final stages of Zealandia's descent. They came from forests that once covered the continent before the sea claimed it. As the land dipped lower, pollen washed into rising waters. Rivers carried it across shrinking coastlines. Floods swept it from valleys that had begun to surrender to the sea. Eventually, it settled upon new seafloors, where it became part of the quiet geological archive that scientists now read. Alongside the pollen were other fragments that felt equally strange in the deep. Some sediments held the remains of shallow water organisms, creatures that thrive only in places where sunlight reaches the seafloor. These organisms form delicate shells or skeletons that settle into sediments when they die. The species found in Zealandia's samples lived in waters bright enough to sustain algae, corals, and other sun-dependent life. Yet the cores that held them came from depths where light could never reach, depths cold and dark, far beyond the reach of even the faintest glow. Their presence revealed that parts of Zealandia once sat just below the surface of shallow seas, not yet claimed by the deep. These regions may have formed lagoons, coastal shelves, or warm inlets where marine life flourished. As the continent continued to sink, these environments faded, the shallow waters deepened, the bright world of sunlight gave way to dim blue. Creatures that once fed on algae or photosynthetic organisms disappeared from the region. Only their shells, carried by currents and buried by time, remained. Other clues told of periods of abrupt change, moments when the environment shifted far more quickly than the long rhythm of tectonic descent. In some layers, coarse sands appeared suddenly, interrupting the fine muds that had settled before them. These sands indicated powerful currents or floods, events strong enough to sweep material from nearby land and deposit it abruptly upon the seafloor. Such layers were reminders of the final years of Zealandia's exposed life, when storms and rising tides carved through the last fragile landscapes. In deeper sections of the cores, chemical signatures revealed changes in ocean temperature and salinity. Some shifts happened over long ages, but others were rapid, marking transitions where the environment changed faster than ecosystems could adapt. These chemical traces hinted at episodes of warming and cooling, at times when sea levels rose more quickly or when currents altered their paths. Each change left a mark in the sediments, a quiet record of a world in motion. One of the most striking discoveries came from layers rich in material that had formed on land, not in the ocean. Fragments of soil minerals, small pieces of charcoal, and particles shaped by wind suggested that parts of the continent were exposed to air in sudden intervals. These materials appeared in narrow bands, as if the land had briefly risen or the sea had withdrawn before returning again. Such moments may have been caused by shifts in tectonic forces or by global sea level fluctuations. They offered brief glimmers of Zealandia's resilience, of times when the continent resisted the ocean's advance before sinking deeper once more. When all these clues were placed together, a vivid image emerged. Zealandia had not disappeared in an instant. It had experienced phases of drowning and exposure. Its forests had shed pollen into rising seas. Its shallows had supported bright ecosystems before darkening. Its rivers had delivered sediments into waters that gradually deepened around them. Its surface had lifted and lowered in gentle pulses as tectonic forces reshaped the region. These fossils and sediments should not exist in the deep ocean, yet they do, because the deep ocean was not always there. It arrived slowly, filling the space left behind by a continent settling into silence. In the quiet forms preserved beneath the Pacific, the memory of Zealandia's final days remains, held delicately in grains of pollen and shells of creatures that once lived in sunlight. And through them, the lost continent continues to speak, offering small yet powerful reminders of the world it once was. Long after most of Zealandia had slipped beneath the Pacific, a few remnants held fast above the rising water. These fragments did not survive because they were spared the downward pull, but because they were the tallest peaks of a once mighty landscape. Today we call them islands. We give them names, build homes on their shores, and admire the rugged mountains that rise above the sea. Yet they are not isolated worlds. They are the last breath of an ancient continent, the highest ridges of a realm now hidden beneath endless blue. Among these remaining peaks, New Zealand stands as the clearest window into the world that once stretched across a region larger than India. The islands of New Zealand are dramatic, with sharp alpine ridges carved by snow, deep fjords shaped by glacial ice, and rolling plains that hold rich soils formed from volcanic ash and eroded stone. These features do not feel like the scattered remnants of a simple archipelago. They feel continental, they feel substantial, and that is because they are. When scientists walk the mountains of New Zealand, they are stepping onto the peaks of Zealandia's long submerged spine. The rocks beneath their feet carry the same chemistry, mineral patterns, and deep crustal signatures found across continental masses around the world. Granite, schist, and ancient metamorphic layers rise in cliffs and ridges, telling stories that stretch back hundreds of millions of years. These are the rocks of a continent, not of the volcanic island chains more common across the Pacific. As researchers followed these clues, they began to trace the geological continuity that links New Zealand to the drowned land beneath the sea. Seafloor mapping revealed that the mountains on land extend seamlessly into ridges below the water. Valleys that cut across the North and South Islands continue as long submerged troughs. Plateaus that sit offshore share the same crustal thickness and composition as the land. Even the faults that shape the New Zealand landscape continue outward, guiding the movement of the ocean floor in patterns that reflect the same tectonic forces. These connections form more than visual echoes. They give scientists a way to interpret the hidden geology of Zealandia by studying the exposed fragments on land. Every fold in the mountains, every uplifted ridge, every volcanic arc preserves clues about the forces that once shaped the entire continent. The faults that cut across New Zealand today are not new lines, written only upon the islands. They are ancient breaks in the crust that stretch far into the submerged regions, recording the slow tearing and bending that weakened the continent long before it sank. In the South Island, the southern Alps rise like a wall against the sky. Their peaks tower above the land, capped with snow and carved by wind. Yet these Alps are only the highest points of a much larger mountain range that continues beneath the sea. Sonar mapping reveals that ridges branch outward from the island's coastline, forming submerged extensions of the same uplifted belt. These hidden ridges resemble the drowned shoulders of a giant whose head remains above water, the rest forever resting below. On the North Island, volcanic activity marks another window into the deeper crust. Volcanoes such as Ruapehu and Tongariro sit along lines of tectonic tension, created by the same forces that shaped Zealandia when it first pulled free from Gondwana. The geothermal features that warm the island, from bubbling springs to steaming valleys, are modern expressions of processes that once affected the entire continent. They are reminders that the crust beneath New Zealand remains alive, adjusting and shifting as it did millions of years ago. Even the coastlines offer clues. In some places, cliffs expose layers of ancient sediments lifted from the seafloor long ago. In others, folded and tilted rock beds show how land once buckled under tectonic pressure. These formations continue offshore in sweeping arcs, traced by seismic surveys that reveal their hidden lengths. To see these patterns is to see the signature of the continent itself, carried forward into every submerged plateau and basin. Beyond the scientific evidence lies something more subtle. New Zealand's landscapes have a scale and weight that feel different from islands born of pure volcanic origins. They hold the gravitas of continental geology, where mountains rise from deep crustal roots and valleys reflect the push and pull of entire plates. The vegetation, too, carries echoes of Zealandia's heritage. Unique species evolved in isolation, much like the life that once shaped the broader continent. Although most of Zealandia's ecosystems vanished long ago, the forests and wildlife of New Zealand preserve hints of that ancient evolutionary story. To walk across the islands today is to step across the surviving summits of a world that once stood proudly above the sea. Each ridge, each mountain, each fold in the land whispers of the vastness that lies beneath the Pacific. The islands do not stand alone. They are small windows into a continental story, fragments of a hidden realm that stretches across millions of square kilometers below the waves. When scientists gaze at New Zealand, they are not simply studying an island nation. They are reading the exposed letters of a long submerged manuscript. Through these peaks, Zealandia reveals itself a little more clearly, offering a glimpse of the continent that once was, and that remains intact beneath the ocean, waiting quietly in the depths. In these islands that are really mountaintops, the memory of Zealandia still breathes, soft and enduring, in stone shaped by time and uplift that has carried it far above the silent world below. As Zealandia settled beneath the Pacific, one might imagine the entire continent slipping downward in a quiet, unified motion. Yet the truth is more intricate. Even while most of the continent continued its slow descent into deeper waters, certain regions rose unexpectedly, as if resisting the larger movement. These contrasting motions, sinking in some places and uplifting in others, formed one of the most delicate and fascinating chapters in Zealandia's story. The forces responsible were rooted in the shifting plates that frame the Pacific, forces that sculpt entire continents through patient, powerful pressure. The edges of Zealandia sit near one of the most dynamic regions of Earth's crust. Along its northern and eastern boundaries, the vast Pacific plate presses inward, sliding beneath parts of Zealandia in a process called subduction. Subduction occurs when one plate bends downward into the mantle, allowing another to ride above it. Where this happens, the overlying plate can be dragged, tilted, or lowered as the descending plate pulls downward. Much of Zealandia's eastern margin has experienced this kind of movement for millions of years, contributing to the continent's gradual sinking. But where the Pacific plate dives beneath Zealandia, another effect emerges. The act of one plate sliding below another generates immense pressure. This pressure travels upward through the crust, folding and thickening it. Even though the continent sinks overall, the force of subduction creates local zones where the land is pushed upward. These zones of uplift rise slowly but steadily, forming mountain belts and ridges that grow taller even as the surrounding areas fall deeper into the sea. Such contrasting movements can feel almost contradictory, yet in the language of tectonics, they coexist naturally. The crust responds differently depending on its thickness, temperature, and the direction of the forces acting upon it. Where Zealandia is thinnest, the downward pull of subduction overwhelms any uplift, causing large regions to sag toward the deep. Where the crust is thicker or reinforced by older geological roots, uplift may win, lifting mountains skyward. New Zealand, which represents the highest peaks of Zealandia, exists largely because of this uplift. Along the boundary where the Pacific plate presses westward, the crust beneath the South Island thickens dramatically. Pressure forces rock upward, forming the Southern Alps. These mountains grow in part because of the strong collision between plates. They rise so quickly in geological terms that erosion struggles to keep pace, trimming their peaks even as tectonics continue to push them higher. Further north, the landscape becomes stranger still. In the region where the Pacific plate subducts beneath the North Island, volcanic arcs form. Magma generated deep underground fills chambers, feeds volcanoes, and creates geothermal activity. While volcanic activity is often viewed as destructive, it also contributes to uplift. Each eruption builds land. Each flow of magma adds new layers to the crust. This uplift may be modest or short-lived, but over time it shapes the landscape in ways that trace the deeper tectonic dance below. Yet only a short distance away from these rising regions, the land sinks steadily. The offshore basins along Zealandia's eastern margin droop under the weight of accumulating sediments. They sag due to the cooling and contraction of crust pulled away from volcanic arcs. They deepen where the Pacific plate drags the edge of the continent downward as it subducts. These basins form long, shadowed valleys beneath the ocean, reminders of the imbalance between uplift in one place and subsidence in another. In the western reaches of Zealandia, a different sort of motion unfolds. Here, the Australian plate interacts with the continent, sometimes pushing upward, sometimes sliding past in a gentle sideways motion. This complex interaction causes certain areas to tilt. Some regions rise gradually, forming offshore ridges. Others sink into broad shelves that stretch toward deeper waters. The alternating rise and fall creates a patchwork of geological zones, each responding uniquely to the forces acting upon it. This strange combination of uplift and subsidence is not unusual for continents resting at plate boundaries. But Zealandia's thin crust makes the contrast sharper. Thicker continents resist bending, They rise more slowly and sink less easily. Zealandia, however, responds with greater sensitivity. Where uplift acts, it lifts sharply. Where subsidence pulls, it sinks deeply. The result is a continent shaped like a breathing landscape, rising and falling in different places as if responding to unseen tides. The story becomes even more textured when we consider the mantle beneath these shifting plates. Subduction drags cold, dense lithosphere into the mantle. As it descends, it can pull the overlying crust downward as well. But in nearby regions, the heat generated by this process can create buoyant magma that rises, reduces density, and gently pushes the crust upward. These opposing effects coexist across surprisingly short distances, shaping Zealandia into a land of contrasting motions. Volcanic arcs, high mountain belts, deep offshore basins, and tilted shelves all emerge from these competing tectonic forces. Every uplifted peak is mirrored by a sunken basin somewhere nearby. Every sideways shift is balanced by changes in vertical motion. Zealandia's entire structure is a record of this long interplay, written in the quiet rise of mountains and the deepening of ocean floors. When scientists study New Zealand's highest peaks or map the hidden valleys beneath the ocean, they are witnessing the living expression of these forces. The continent is not static. It continues to move, breathe, and reshape itself under the slow but constant influence of tectonic pressure. Some parts rise toward the sky while others slip deeper into the sea, each motion reflecting the deep conversation between plates that began when Zealandia first broke from Gondwana. This interplay of uplift and subduction shaped the continent's final fate, creating the fractured, beautiful landscape we see today, above and below the waves. And through this ongoing dance of rising and sinking, Zealandia continues to reveal both its ancient past and the quiet geological rhythms that still guide its form. As Zealandia continued to rise in some places and sink in others, another set of features slowly carved itself into the continent's long submerged frame. These features were not the broad, sweeping ridges of mountain belts, nor the wide plateaus that hinted at vanished landscapes. They were sharper, more pointed, formed by fire rather than by folding. They rose from deep within the earth, shaped by heat that moved upward from the mantle. These volcanoes, scattered across both land and seafloor, became markers of Zealandia's hidden skeleton. Along the edges where Zealandia meets the restless Pacific plate, volcanic arcs trace the boundary like glowing threads woven through stone. These arcs form when the Pacific plate, enormous and ancient, slides beneath the lighter crust of Zealandia. As the plate sinks into the mantle, it releases water and minerals that trigger melting in the mantle above it. The melted rock rises, sometimes slowly, sometimes in great bursts, and eventually breaks through the crust as volcanoes. In New Zealand, these volcanoes form a dramatic chain across the North Island. Peaks such as Ruapehu, Gauruho, and Tongariro stand like sentinels along the edge of the continent's submerged body. Their slopes are shaped by layers of cooled lava, ash, and pumice. Each eruption adds new height, new texture, and new stories to the volcanic arc. When the land trembles with their rumbling, it echoes the deeper motions of plates shifting beneath the surface. Farther north, the region around the Bay of Plenty reveals even more volcanic forms. White Island, known for its continuous steam and sulfur clouds, rests atop one of the most active segments of the continent's crust. It rises from the sea as a reminder that Zealandia, though hidden, remains alive with heat. Its vents and fumaroles speak in quiet hisses and gentle plumes, carrying messages from the deep mantle to the surface. Yet these visible volcanoes are only part of the story. Beyond the shores of New Zealand, volcanic arcs stretch into the ocean, continuing Zealandia's skeleton far beyond where sunlight reaches. Beneath the waves lie underwater peaks shaped by ancient eruptions. Some are tall enough that their summits once broke the surface as islands. Others never touched the air, growing quietly in the dim blue of the ocean's upper layers before the cooling crust caused them to sink. These underwater volcanoes reveal the long history of hot zones, areas where magma once rose through cracks or weaknesses in the crust. Some peaks formed where the plate boundary shifted in unexpected ways, creating brief windows for magma to burst through. Others formed where the crust stretched, pulling apart just enough for molten rock to escape upward. When scientists mapped these submerged peaks, they found patterns that mirrored the structures visible on land. Lines of underwater volcanoes traced the ancient tectonic boundaries with remarkable clarity. Even though these boundaries no longer erupt with the same intensity, the peaks remain like footprints of past geological fire. They mark where the earth once opened, where heat once flowed, and where the crust responded to forces that shaped the continent's fate. Some of the underwater volcanoes rise from areas where Zealandia's crust has fractured deeply. These fractures act as conduits for magma, allowing it to reach the surface even in regions where subduction is not strong. In such places, volcanic peaks form small clusters, islands of stone that rise from the seafloor like the tops of lost mountains. Many of these features are ancient, their surfaces softened by erosion and coated with sediments, but their cores still hold the chemical fingerprints of their fiery origins. Other volcanic structures lie along the northern extension of Zealandia, where the Pacific plate curves and changes direction. In this region, the shifting geometry of the plates creates alternating zones of compression and extension. Each zone affects how magma moves. In some areas, pressure keeps magma trapped deep below. In others, tension opens pathways, allowing magma to rise and create new volcanic forms. The underwater mountains that emerge from this interplay show how dynamic the boundary has been across millions of years. Even near the southern reaches of Zealandia, submarine volcanoes rise from the seafloor. Some formed when hot spots, regions of unusually warm mantle, drifted beneath the continent. These hot spots created chains of volcanoes, much like the Hawaiian Islands, though most of Zealandia's equivalents have long since sunk below the waves. Their presence demonstrates how Zealandia passed through zones of heat that left permanent marks on its crust. On the South Island, volcanic remnants stand as mute witnesses to the continent's fiery past. Banks Peninsula and Otago Peninsula are two of the clearest examples. Though now eroded and softened by time, they are the remnants of large shield volcanoes that erupted millions of years ago. Their shapes, gentle yet unmistakably volcanic, rise from the land like memories of an earlier geological age. Throughout Zealandia, these volcanoes, both above and below the sea, form a deep network of clues. They show where the crust bent, where it stretched, where it fractured, and where it yielded to pressure from the mantle. They outline the edges of tectonic plates, revealing how the Pacific plate's relentless motion sculpted the continent from below. They mark regions where heat once pulsed through the crust, creating new land even as other parts of the continent sank into the ocean. Together, these volcanic arcs and underwater peaks create a kind of skeletal map, a map not of living bone, but of fire, pressure, and patient geological change. They define the hidden framework of Zealandia, the unseen architecture that shaped its rise and fall. Even in silence, the volcanoes of Zealandia tell their story. They speak of heat moving upward through the earth. They speak of plates colliding and separating. They speak of a continent shaped not only by water and wind, but by the deep, glowing heart of the planet. And through them, the memory of Zealandia's ancient fire lives on, quietly illuminating the vast and beautiful structure of a world now hidden beneath the sea. Long before Zealandia drifted away from Gondwana, long before its mountains rose and its forests bent in the wind, the crust beneath it cooled from glowing mantle rock into solid stone. In that moment of cooling, something subtle but permanent settled into its structure. Tiny minerals aligned with Earth's magnetic field, arranging themselves like countless compass needles frozen in place. These minerals became quiet record keepers, preserving the orientation and intensity of the planet's magnetism at the time the rocks formed. Millions of years later, when most of Zealandia had slipped beneath the Pacific, those magnetic signatures remained. They rested in the crust like faint lines drawn across a forgotten manuscript, lines that scientists would one day learn to read. These magnetic lines, patterns invisible to the eye yet unmistakable in the data, became one of the clearest clues that Zealandia is not a patchwork of unrelated fragments, but a single, coherent continent. To uncover these patterns, researchers used instruments capable of sensing the faint tug of magnetism through layers of sediment and water. As survey ships moved slowly across the ocean, they trailed magnetometers behind them. These instruments recorded the magnetic field beneath the waves, tracing its subtle rises and dips. The data formed long ribbons of information, each point marking the hidden behavior of minerals buried far below. When scientists spread these ribbons across a map of the Pacific floor, something remarkable emerged. The magnetic signals beneath the water around New Zealand aligned in long, sweeping arcs that matched those found on stable continents. These arcs did not belong to the chaotic patterns of ocean crust, which form in symmetrical stripes at mid-ocean ridges. They reflected the far more intricate signature of continental crust, shaped by stretching, folding, and ancient heat. In the southern Alps, these magnetic lines curve gracefully beneath the mountains, hinting at the deep roots that still anchor them. Offshore, the lines continue with the same curvature, tracing the submerged extension of the range beneath the Pacific. Where plateaus lie hidden beneath shallow seas, the magnetic fingerprints remain strong, revealing that these drowned lands once stood as part of the same continuous crust. In some regions, the magnetic lines show gentle waves, the result of the crust cooling at uneven rates long ago. In others, the lines are sharply bent, marking zones where tectonic forces twisted the crust during the rifting from Gondwana. These bends correspond with known fault systems, showing how the continent stretched and cracked as it drifted apart. No matter where scientists followed the magnetic patterns, they found continuity. Every ridge, valley, and plateau shared the same underlying orientation, the same ancient memory. This coherence is significant. Oceanic crust forms in strips that alternate polarity as Earth's magnetic field flips over time. These strips create a symmetrical pattern, like the stripes of a barcode spreading outward from a ridge. But Zealandia's patterns tell a different story. They lack the symmetry of ocean crust. They hold the complexity of land shaped by deep geological time. They reflect molten rock that cooled slowly beneath the thickness of a continent, not the rapid eruptions of oceanic ridges. Some of the most striking magnetic signatures come from regions far offshore, where the seafloor might appear at first glance to be ordinary ocean crust, yet the magnetic fingerprints reveal something more. They show the same chemical and magnetic identity found on the exposed land of New Zealand. This continuity proves that the submerged areas are not separate blocks scattered by chance, but the submerged body of a single continent that once stretched far wider than the islands we see today. Scientists also found magnetic anomalies that trace the edges of Zealandia's rift zones. These anomalies form irregular patterns shaped by the violent processes that stretched the continent thin. Younger anomalies overlap older ones, marking moments when new crust formed or when ancient crust was reheated and altered. These overlapping layers help reconstruct the sequence of events that led to Zealandia's separation from Gondwana, revealing how each phase of stretching left an imprint in the magnetic record. In the northern regions, where volcanic arcs curve across the ocean floor, magnetic maps show zones of heightened intensity. These zones come from rocks formed in volcanic heat, their minerals aligned with Earth's magnetic field at the moment of eruption. The arcs curve in harmony with those seen on land, confirming that the underwater volcanoes are part of the same ancient processes that shaped New Zealand's fiery heart. Even the deepest basins surrounding Zealandia carry faint echoes of the continent's magnetic identity. Though buried beneath thick layers of sediment, the crust below retains its ancient orientation. These faint signals whisper that beneath the ocean's quiet surface lies a world as geologically rich as any land we walk upon today. Together, these magnetic lines form a map of Zealandia's hidden skeleton. They outline its mountains, its basins, its ancient faults, and its volcanic arcs. They show where the crust cooled, where it bent, where it fractured, and where it drifted. Most importantly, they show that all these features share a single origin. They belong to a continent that once stood above the waves, unified by a deep and ancient crust. In reading these magnetic fingerprints, scientists gained one of the clearest confirmations that Zealandia is real, not imagined, not misinterpreted. The patterns are too coherent, too consistent, too continental to be anything else. Beneath the Pacific lies a world shaped by the same forces that build every great landmass on Earth. And though Zealandia rests in silence now, the magnetic lines within its crust continue to speak, carrying the memory of a continent that once touched the sky. With each new discovery across the quiet floor of the Pacific, the outline of Zealandia becomes clearer. Mountain ranges, volcanic arcs, continental plateaus, and magnetic fingerprints have all revealed pieces of its story. Yet, for all that scientists have uncovered, far more remains hidden in the deep. Much of the continent has never been touched by instruments or explored by submersibles. Even the most detailed maps smooth over mysteries that lie beneath layers of sediment or within basins too deep for light to reach. When researchers look across the submerged landscape, they see vast basins that remain almost entirely unexplored. These basins form the lowest parts of Zealandia, where the crust sagged most deeply during the continent's long sinking. Over millions of years, they filled with sediments washed in from the higher ground. Each layer carries fragments of ancient soils, minerals, and organic material from the forests and rivers that once lived on the continent's surface. These basins have become vaults of geological memory, holding stories that have not yet been read. Some of these basins stretch for hundreds of miles. Their floors are smooth and dark, covered by fine grains that settle from the water column inch by inch. Others contain ridges and small rises that hint at deeper structures buried beneath the sediment. These features may be the remains of old river valleys, volcanic fields, or even smaller mountain ranges now flattened by time. The only way to know is to go deeper, but reaching them is no simple task. Beneath the thick blankets of sediment, there may be fossils unlike any discovered so far. The few cores drilled in shallow regions of Zealandia have already brought up pollen, plant fragments, and hints of terrestrial life. If similar layers lie buried in the deeper basins, they could hold remains of animals that once roamed the continent. Perhaps the bones of large birds shaped by isolation, or the shells of reptiles adapted to warm coastal plains. Fossils from ancient forests could reveal species that never survived elsewhere, trees that bent toward a sun long gone from that horizon. There may also be traces of ecosystems that lived during the transition from land to sea. As the continent sank, some environments would have shifted rapidly, filling with new species adapted to shallower waters. Coral communities may have flourished on high ridges before they were drowned. Creatures that lived in estuaries and tidal flats might be preserved in layers where freshwater and saltwater once mingled. These transitions are rarely captured so clearly in the fossil record. Zealandia offers the possibility of seeing moments when entire landscapes changed their nature, preserved quietly beneath the deep. But reaching these treasures is a profound challenge. The ocean above Zealandia is vast and heavy. In many areas, the water column stretches for miles. Lowering a drill through that water, then through layers of sediment, then into the crust itself, requires extraordinary precision. Even the most advanced drilling ships struggle in waters where strong currents tug at equipment and where waves can disrupt delicate machinery. Drilling into continental crust beneath such depths is not only technically difficult, but extremely costly. Each core sample demands careful planning, specialized vessels, and months or years of preparation. Scientists must choose their locations with great care, guided by maps that are still incomplete and by models that do not yet capture every nuance of Zealandia's hidden geology. The deeper basins present an even more daunting challenge. Some lie in regions where the crust has fractured so extensively that drilling could destabilize equipment. Others sit beneath layers of sediment so thick that core samples might never reach the older rocks below. There are places where the seafloor is too rugged or too unstable to support drilling at all. Yet despite these obstacles, the desire to explore remains strong. Each time new data arrives from mapping missions or seismic surveys, scientists discover hints of structures that raise new questions. A narrow ridge hidden beneath sediments suggests a fault that has not yet been studied. A cluster of anomalies hints at volcanic features no one has mapped. A curved depression resembles the remains of an ancient lake basin, preserved beneath the ocean like a memory waiting to be revealed. Even the chemical signatures within sediments offer clues to unseen events. Sudden changes in mineral composition point to shifts in climate or eruptions that send ash across the continent. Layers rich in organic material suggest periods of warmth and abundance, while barren layers reveal intervals of cooling or drought. Each sample holds the potential to uncover a chapter of Zealandia's history that cannot be learned from its surviving fragments on land. There is also the possibility of finding something unexpected. Entire regions of the continent have remained untouched since they sank. Their rocks have not been weathered by human hands or reshaped by industry. They lie in a state closest to how they existed millions of years ago, hidden beneath miles of water and untouched by modern life. For scientists, this makes Zealandia a rare and precious window into deep time. As exploration continues, the deeper basins will slowly give up their secrets. It may take decades for drilling technology to reach the most remote areas. It may take generations to map every ridge and fold. But beneath the quiet ocean, the continent waits, carrying stories that have not yet been told. Stories of life, of fire, of sinking land, of changing seas. Stories that lie in the sediment, in the rocks, and in the spaces between them. In these unexplored depths, Zealandia holds the possibility of discoveries that could reshape our understanding of Earth's past. And though much of the continent rests beyond our immediate reach, its unseen world continues to whisper its presence through the layers of stone that rest far below the waves. For decades, Zealandia lived mostly in the realm of suggestion. Its mountains slept beneath the Pacific. Its magnetic lines whispered hints of a hidden past. Its fossils and sediments spoke softly of forests and rivers that once breathed beneath open sky. But the scientific world is patient. Evidence gathers slowly, layering itself like sediment on a quiet seafloor. And then, in the year 2017, a single expedition brought all those hints into focus. It began with a ship designed to read the Earth in the deepest way possible. The vessel was long and pale against the ocean, steady even in shifting winds. It carried laboratories, lifting cranes, and drilling towers that rose like slender watchtowers above the deck. This was the Joid's Resolution, a ship built not for speed or travel, but for reaching down into the memory of the planet. Above deck, its machinery clinked and hummed. Below deck, teams of scientists prepared for the long days ahead, ready to coax stories from stone. The ship sailed into the waters above Zealandia, navigating plains of ocean that hid an entire continent beneath them. The surface gave no sign of what lay below. There were no islands in sight, no rising peaks, no jagged silhouettes against the horizon, only the shifting blue, calm and unbroken. Yet beneath that calm rested the edges of Zealandia, the submerged shoulders of a landmass waiting for the right moment to reveal itself. The crew lowered the first drill into the water. It descended slowly, guided by cables as thick as tree trunks. The drill passed through layers of currents, then through darker and colder water. Finally, it touched the seafloor, a world of quiet sediment and ancient minerals. The drilling began, carving downward inch by inch. Each stroke pushed deeper into time. The sediments that gathered inside the drill pipe belonged to eras when Zealandia was young, when its forests rustled in warm winds and its rivers traced lines across open plains. When the first core rose to the surface, it came in a long cylindrical tube, streaked with layers of mud, ash, and stone. The scientists carried it gently into the lab. They opened it carefully, slicing it into sections. Inside were colors that spoke of different climates, fine grains arranged in patterns that hinted at shifting environments. And within those layers lay tiny fragments of fossilized life that could not have formed in deep water. There were pieces of pollen, still holding the shapes of ancient plants. Their grains glittered faintly under the microscope. They belonged to forests that once grew high above sea level. There were shells of shallow water organisms, creatures that needed sunlight and warmth to survive. These remains had no place on the deep seafloor where they now rested. Their presence meant that the region had once stood far higher, a place where land and light once met. Then came samples of rock pulled not from soft sediments, but from hardened crust. These stones carried the mineral signatures of continental origins, light-colored granites and metamorphic fragments filled with patterns that form only within thick continental crust. None of these minerals could be produced by oceanic crust, which forms quickly and simply at mid-ocean ridges. These stones told a different story. They told of deep time, slow cooling, and the ancient heat of a continent being born. Sample after sample carried the same message: fossils from land, minerals from continental roots, sediments washed from rivers that once existed above water, rock layers that fractured and folded in ways typical of continental geology. Everything pointed to the same truth. The land beneath the Pacific was not a scattered set of fragments. It was the top of a continent, drowned but whole. When the scientists assembled their findings, the picture became unmistakable. Zealandia was not a myth. It was not a poetic idea or a geological curiosity. It was a continent, large and coherent, shaped by all the forces that form the continents we know today. Its crust was thick enough to classify it. Its structures were old enough to place it firmly in Earth's geological history. Its features aligned with the definition of a continent used around the world. In quiet conference rooms aboard the ship, the team shared their results. Their voices carried a calm reverence, as if they were not merely discussing data, but unveiling something long forgotten. Each core offered a page of Zealandia's story. Together, they formed a geological book written across millions of years. And so, in the year 2017, the scientific community finally recognized what the Earth had been holding in silence. Zealandia became officially acknowledged as the eighth continent. It was not lifted above the waves. It did not rise in triumph. Instead, it emerged in the minds of those who studied it, its identity rising from the deep through evidence and patience. The Joid's resolution continued its journey, leaving behind calm ripples that faded into the Pacific. But beneath those waters, Zealandia remained, now seen not as empty seafloor, but as a continent resting quietly below, its story finally beginning to be understood. When the findings from the 2017 expedition settled into the scientific world, they did more than place a submerged continent on the map. They nudged geology itself into a quieter, deeper reflection. Zealandia, resting beneath the Pacific in patient silence, offered a new way of seeing the planet. Its existence reminded researchers that Earth's surface, though familiar, is far from fully understood. The discovery was not simply about naming a continent. It was about widening the frame through which we view the planet's past and the forces that have shaped it. For generations, the concept of a continent was treated almost as a fixed idea defined by clear examples. Africa, Asia, Europe, North America, South America, Antarctica, Australia. These landmasses stood high above the oceans, their outlines visible on every schoolroom globe. They felt permanent, unmovable, complete. But Zealandia revealed that continents do not owe their identity to the visibility of their summits. They are defined instead by the thickness of their crust, the age of their rocks, and the deep structures that guide their motion. Zealandia showed that a continent can lie beneath the ocean, nearly invisible, yet retain every feature that marks a continental body. It forced scientists to look past the surface, to consider the Earth not only as a world of coastlines and mountains, but as a sphere shaped from within. The definition of a continent expanded, becoming more rooted in geology than in geography. It became a concept shaped by the nature of Earth's crust rather than the limits of human perception. With this shift came a deeper realization. If Earth can hide a landmass as large as Europe beneath the oceans, then our understanding of the planet's structure is far from finished. Zealandia encouraged scientists to search beyond the obvious, to question whether other landmasses may be waiting in silence, concealed by water or by sediment. Already, smaller fragments such as Mauritia and Greater Adria had hinted at this possibility, but Zealandia, vast and coherent, made the truth undeniable. Our planet has erased and buried more than we once imagined, and it may continue to do so long after we are gone. This recognition opened the door to a new era of geological reconstruction. Plate tectonics, the slow dance of crustal plates across Earth's surface, gained new complexity. Until recently, scientists traced the motions of continents by examining their shorelines, their magnetic signatures, and the scars left by ancient collisions. But with Zealandia's unveiling, it became clear that submerged continents must also be woven into the grand story. The plates beneath the oceans were no longer seen as simple backgrounds for the activity on land. They were revealed as partners in the shifting of continents, carrying fragments, stretching boundaries and reshaping the world beneath the waves. Zealandia offered new threads to follow. Its submerged plateaus and mountain belts became clues for reconstructing how Gondwana fractured and dispersed. Its volcanic arcs traced the path of the Pacific Plate as it carved into the continent. Its basins recorded how the Earth's mantle cooled and reshaped the crust over millions of years. The discovery encouraged researchers to refine plate maps, adjust ancient coastlines, and imagine new configurations of past continents. With every refinement, Earth's history became clearer, more intricate, and more interconnected. This new phase of reconstruction also deepened our understanding of tectonic vulnerability. Zealandia demonstrated how thin continental crust can be stretched until it loses buoyancy, sliding quietly into the sea. Through this story, geologists learned more about how continents can weaken, fragment, and eventually sink. These insights carry implications for other regions where crust thins or stretches, from the East African Rift to the margins of the South China Sea. The forces that shaped Zealandia continue to act on Earth today, sculpting landscapes in slow and gentle motions. As scientists applied these insights more broadly, a deeper truth emerged. Earth is not a static world with fixed continents. It is a planet that builds and erases landmasses, lifts mountains into the sky, and sinks entire continents into the deep. It is a world where the surface hides the slow churn of the mantle, where ancient landscapes drift across latitudes like leaves on a long tide. The discovery of Zealandia did not just alter a map, it reminded us that the map itself is temporary, a momentary snapshot in Earth's long unfolding. In laboratories and research vessels across the world, the story of Zealandia continues to shape how scientists interpret new data. Seismic surveys, gravity maps, and magnetic scans are now read with a richer understanding of what they might reveal. Instead of dismissing anomalies beneath the oceans as simple variations in the seafloor, researchers now consider the possibility of hidden crustal bodies, continental fragments, microplates, lost worlds buried by rising seas. Through Zealandia, geology has become more curious, more patient, and more aware of its own limitations. The continent's quiet presence beneath the Pacific reminds us that Earth holds secrets not because they are small, but because they lie just beyond the reach of ordinary perception. The discovery reshaped geology by widening the door to those secrets, inviting scientists to keep exploring, to keep listening to the signals rising from the deep. And in doing so, it brought the story of our planet into sharper focus, revealing that even beneath the calmest waters, continents breathe, shift, and wait to be understood. As the story of Zealandia unfolds, it becomes clear that the Earth has performed this quiet, vanishing act before. Zealandia is not an isolated wonder. It is part of a larger pattern, a reminder that continents have come and gone across the ages, slipping beneath oceans or being folded into larger landmasses until only fragments remain. These lost worlds linger like faint echoes, revealed only when science turns its attention to the right clues. One of these hidden lands lies beneath the gentle swells of the Indian Ocean. It is called Mauritius. From the surface, there is no sign of it. The water stretches calmly in all directions, reflecting sunlight in soft ripples that give no hint of the land below. Yet deep beneath those waters rests the ancient heart of a continent that once stood near Madagascar in India, long before those regions drifted into their modern shapes. Mauritius' story emerged slowly. Geologists studying volcanic sands on Mauritius, a small island in the Indian Ocean, discovered tiny crystals of zircon. These crystals were astonishingly old, far older than the island itself. They carried the resilience of gemstones that had endured billions of years, surviving heat, pressure, and burial beneath ancient landscapes. Their presence on the young volcanic island suggested that something older lay beneath it, something that predated the ocean crust on which the island sat. As scientists mapped gravity fields and seismic waves in the region, a picture began to form. Under the basaltic floor of the Indian Ocean, there were fragments of continental crust, thicker and more complex than the oceanic crust surrounding them. These fragments belonged to Mauritia, a continent that began to break apart when the supercontinent Gondwana dissolved into separate worlds. Mauritia did not withstand the stretching that followed. Like Zealandia, it thinned until it could no longer float high on the mantle. Its pieces slipped beneath the waves, leaving behind only scattered remnants buried under volcanic layers. Mauritia reveals that continents can fail not through catastrophe, but through slow and graceful surrender. It shows how delicate the balance of crustal thickness can be, and how a region left too thin or stretched too far can sink quietly into the deep. Its fragments rest today in silence, known only through crystals that survived the fall. Another lost continent lies hidden beneath the southern edges of Europe. It is called Greater Adria. For a long time, the mountains of Italy, Greece, and the Balkans puzzled geologists with their strange mix of rock types and the unusual angles at which their layers tilted. These rocks seemed out of place, like chapters from different books bound mistakenly together. The reason for this confusion became clear only when scientists traced the motion of tectonic plates far back through time. Greater Adria was once a large continental body sitting near the northern shores of ancient Africa. Over tens of millions of years, it drifted slowly toward Eurasia. The collision was not a single dramatic event. It was a long and steady push, like two great sheets of fabric folding into one another. As Greater Adria pressed into Europe, parts of it were scraped upward, forming mountain belts. Other parts were dragged downward, pulled into Earth's deep mantle. Most of Greater Adria now lies buried beneath Italy and the surrounding regions. Only the peaks that were pushed upward remain exposed. These mountains, rising in serene arcs, hold rocks that once lay at the floor of shallow seas or in the quiet interiors of the continent. They are the surviving whispers of a landmass that no longer exists as a coherent whole. The submerged and fragmented state of Mauritia and the buried remains of Greater Adria reveal something important about Earth's character. Our planet is not fixed or still. It lives through cycles of creation and destruction. Continents drift apart until their crusts stretch thin. They collide with others until their edges wrinkle and break. They rise into mountain ranges or collapse into trenches. The surface we know is only a moment in a long sequence of shifting and reshaping that has continued for billions of years. These lost continents also show that permanence is an illusion on Earth. What seems solid and unchanging at the surface can transform entirely when viewed from the perspective of deep time. A continent can rise from the sea, flourish with forests and animals for millions of years, and then slowly sink or be consumed by other plates. Its memory survives only in crystals, rock layers, or seismic echoes. As we consider Mauritia, Greater Adria, and Zealandia together, a pattern becomes clear. Earth holds within it a quiet volatility. Land masses form, evolve, fracture, and fade. Some leave mountains behind, others leave nothing but fragments hidden underwater or folded deep within the crust. In understanding these vanished worlds, we come to see our planet not as a completed puzzle, but as a story still being written, shaped by forces that move slowly yet never pause. Through the long story of Zealandia, and through the quiet echoes of other lost continents, a deeper truth begins to take shape beneath the narrative. It is a truth that has always been part of Earth's nature, yet it often hides beneath the familiar rhythm of everyday time. When we stretch our view outward into deep time, when we imagine millions of years passing like gentle breaths, the world reveals itself as something far more fluid than it appears. Nothing on Earth is permanent. Continents rise, shift, break apart, and sink again. Even the most stable landscapes are only temporary arrangements, brief chapters in a much larger book. To understand how continents disappear, we must imagine the planet not as a solid and unchanging sphere, but as a living surface resting upon restless foundations. Far below the crust, the mantle moves in slow and silent convection. Heat rises from the interior, carrying rock that behaves almost like a thick and patient liquid. Cooler rock sinks in return, pulling plates along the surface. These motions are subtle across human lifetimes. Yet across deep time, they carry enough force to tear continents apart or fuse them together. The process begins with creation. Continents first form when lighter, buoyant crust accumulates above the mantle. This crust may grow through volcanic eruptions, colliding island arcs, or the slow addition of granitic materials over millions of years. In some eras, like the formation of Gondwana or Pangaea, continents draw together, forming vast supercontinents that reshape life and climate. Peaks rise, forests spread, and river systems carve through new land. But this moment of unity is only one phase in a never-ending cycle. Eventually, the forces that created a continent begin to pull it apart. Heat rises unevenly within the mantle, and where the heat is strongest, the crust stretches and thins. Cracks appear, first as small fractures, then as widening rifts that open gently over time. Lakes fill these rifts. Later, oceans follow. Once the crust thins enough, its buoyancy fades. The land begins to sink. Little by little, valleys deepen, shores retreat. What was once high ground becomes a low plain. Over geological ages, these plains may slip beneath the sea, swallowed by the quiet persistence of rising waters or the slow weight of cooling crust. This cycle of stretching and sinking played out in Zealandia's story, but it is not unique to it. Across deep time, continents have disappeared in many ways. Some are pulled downward at subduction zones, where their edges are dragged into the mantle and recycled. Others fracture so thoroughly that their fragments drift apart and vanish beneath new oceans. Some experience uplift first, rising into mountain ranges, only to collapse and erode until there is nothing left but worn-down roots hidden beneath younger layers of sediment. In this perspective, land is never fully lost where one might expect. Even when a continent sinks beneath the waves, parts of it survive as clues. The mantle carries its mineral signature. Ocean sediments bury its last forests. Fossils press their shapes into stone, waiting to be uncovered millions of years later. Tectonic echoes linger in magnetic lines or gravity fields, subtle fingerprints of a world that once stood in sunlight. Deep time also reveals a more surprising truth. Land does not only disappear, it rises again in places where pressure builds or where the mantle grows warm and pushes upward. Entire mountain ranges, such as the Himalayas or the Andes, were once buried crustal fragments that found new life in collision zones. In other places, volcanic hotspots push through the crust, building islands in regions where no land existed before. The planet is always sculpting itself, always balancing what it raises with what it buries. Over millions of years, this process creates a world in constant motion. What appears still to us is only a momentary pause in a slow planetary dance. Shorelines drift, islands emerge from fire, valleys stretch into basins. Continents themselves wander across the globe, carried by the currents of the mantle like rafts on a deep and ancient sea. When they collide, mountains rise. When they separate, oceans bloom between them. And when their crust grows too thin or too weak, they sink into the depths. Through this lens, the disappearance of a continent is not a rare tragedy. It is part of Earth's natural rhythm, a reminder that permanence is a story we tell ourselves because our lifetimes are short. The planet, however, measures time differently. It creates and erases landscapes across spans so vast that they cannot be felt day by day. Yet, when we step back and watch the pattern unfold, we see the truth clearly. Continents are born, transformed, hidden, and sometimes erased. They do not vanish through sudden violence, but through the slow and steady workings of a planet that is always shifting, always evolving, always writing and rewriting its own map. In this perspective, Zealandia is not merely a lost land. It is a testament to Earth's deep time and to the quiet cycles that shape the world beneath our feet. All throughout this journey, we have followed Zealandia as it shifted, fractured, thinned, and finally drifted beneath the Pacific. Its story is written across millions of years in patterns so long and slow that they blur together when viewed through human eyes. And it is here, in this quiet opening between what we can see and what truly happens beneath our world, that another truth begins to emerge. The earth moves in ways that our senses were never built to perceive. We walk across a surface shaped by time frames far larger than our own lives. And because of that, most of its great transformations unfold unnoticed. Human beings evolved on a landscape that seemed still. Grass grows, rivers meander, mountains shed grains of stone that drift down their slopes, but the continents themselves appear fixed. They do not tremble under our feet or shift like restless animals. Their journeys span spans of time so immense that even whole civilizations rise and fall while the land moves only by inches. Our minds, shaped by lives that last decades, cannot easily grasp motions that spread across tens of millions of years. To us, the earth appears stable, permanent, familiar, yet beneath this surface calm, the crust behaves more like a slow-moving ocean of rock. Continents drift through deep time the way clouds drift through the sky, only at a pace so gentle that no living creature can track it. Mountain ranges rise as plates press together, but they do so at rates no faster than the growth of fingernails. Oceans widen as rifts open, though the motion is slower than the pace at which continents erode. Vast landmasses stretch, thin, and sink in movements that feel almost dreamlike when viewed against the span of human memory. In this perspective, continents are not fixed structures. They are fluid shapes being reshaped by gravity, heat, pressure, and the slow breathing of the mantle beneath them. They bend and bow. They lift and fall. They carry forests, deserts, and seas along paths stretching across thousands of miles. And all of this happens in a silence so complete that no person could sense it through touch or sight. Zealandia is perhaps the clearest example of this hidden motion. For millions of years, it drifted away from the remnants of Gondwana, its crust gradually thinning until it could no longer rise above the sea. The forests that once covered it faded, the rivers vanished, its mountains sank until only their highest peaks survived as islands. Yet to any creature living during those changes, the transformation would have seemed non-existent. A slope might have lowered by a tiny fraction in a lifetime. A shoreline might have moved so slowly that no one could have noticed. Even if humans had been there, the continent's disappearance would have unfolded beneath the threshold of their senses. This quiet sinking reveals something about our relationship with the earth. We perceive change only when it is rapid enough for our limited span of life. Earthquakes and storms, eruptions and floods, these are the events we notice. But the changes that shape the planet itself move to a rhythm that does not match our own. They are gentle, persistent, almost meditative. Continents drift like slow shadows. Basins deepen like long and patient breaths. Ranges rise with the steadiness of unfolding stone. Because we evolved within these long cycles, our understanding of Earth often assumes a stillness that is not truly there. We draw maps as if borders and outlines were eternal. We treat mountains as if they have always existed exactly where we find them. We gaze at the sea without imagining entire worlds hidden beneath it. Zealandia reminds us that much of the planet is concealed not because it is small or distant, but because the scale of its story lies beyond the reach of human perception. We are creatures of moments. Earth is a creature of ages. Our senses were shaped by days and seasons, while Earth's surface flows across time frames that stretch far beyond imagination. This mismatch means that we can stand on a shore without knowing that the land beneath our feet is slowly drifting north. We can climb a mountain that is only the exposed edge of a crustal root, still rising from the force of an ancient collision. We can sail across waters that hide plains, valleys, and mountain chains that once echoed with the sounds of wind and life. In this way, Zealandia is a quiet revelation. It is a reminder that the earth holds structures we cannot see, and that some of the most extraordinary stories lie not above the surface, but beneath it. Its outlines are known only through tools designed to stretch our senses outward. Satellites that measure gravity across the planet, ships that scan the seafloor with pulses of sound, magnetic maps that capture the imprint of ancient eruptions. Through these tools, we extend our perception into realms that human eyes cannot naturally reach. And when we do, the world becomes larger. The continents seem less like fixed pillars and more like drifting shapes carved by time. The oceans feel less empty. The seafloor becomes a landscape of its own, filled with clues that hint at the planet's hidden past. Zealandia stands as a quiet invitation to look deeper, to accept that much of Earth's story unfolds beyond the limits of our senses, written in motions too slow for us to feel, but powerful enough to reshape the face of the world. As we follow these hidden shifts, we come to understand that the earth we walk on is not the earth that once existed, nor the earth that will exist in ages yet to come. Continents behave like liquid landscapes in deep time, and Zealandia is a reminder of how much lies beyond the reach of human sight, waiting gently for discovery. Even with all the discoveries that have risen from the quiet seafloor, Zealandia remains a continent wrapped in mystery. Much of what we know comes from scattered surveys, distant echoes of seismic waves, and a handful of precious cores lifted from the deep. These clues have allowed scientists to sketch the outline of this hidden land, to trace its mountains and basins, and to sense its long drifting history. Yet, when viewed through the soft lens of deep time, a great portion of its story still lies untouched. Most of the continent rests beneath water that has shielded it for tens of millions of years, and that water keeps many of its secrets close. Mapping a continent underwater is unlike mapping a continent on land. On the surface, mountains and valleys announce themselves openly. Even the worn shadows of ancient rivers leave their marks in the landscape. But beneath the ocean, those same shapes hide beneath layers of sediment, under shifting currents, and within vast stretches of darkness that sunlight has never reached. Ships passing above can send pulses of sound to trace the contours of the seafloor, but these maps often lack fine detail. They are broad strokes, the outlines of a portrait rather than the full image. Because of this, large regions of Zealandia remain only faintly drawn. In some areas, the seafloor has never been scanned closely. The ocean is immense, and research ships must choose their routes carefully. Weather, depth, and distance create natural limits. Some basins are so deep, and some ridges so steep, that only a handful of measurements exist. Between these measurements lie gaps, subtle and quiet, where entire chapters of geological history may rest. Scientists sometimes describe these unscanned regions as blank spaces, not in the sense of emptiness, but in the sense of pages waiting to be read. Even the boundaries of Zealandia are still not fully understood. A continent, when submerged, does not reveal its edges easily. The crust thins gradually at its margins, fading into oceanic crust that spreads outward from mid-ocean ridges. In some places around Zealandia, this transition is sharp, marked by fractures and steep slopes. In other places, the boundary blurs into a gentle slope of mixed materials. Determining precisely where the continent begins and the oceanic crust ends requires detailed seismic profiles and samples pulled from beneath layers of sediment. These surveys take time, patience, and careful interpretation. Many regions still hold uncertainties, their true structure hidden beneath silence and depth. The geological fabric of Zealandia, too, remains incomplete. Scientists have gathered samples of granitic rocks and sedimentary layers that confirm its continental nature, yet these samples represent only a tiny portion. Much of the continent has never been drilled, never been touched by human tools, never been illuminated by research lights. Its interior regions may contain volcanic arcs that have not yet been mapped, fault systems that reveal ancient tectonic stresses, or plateaus that hold clues to how the continent once rose and fell through the ages. Each gap in our knowledge hints at greater complexity beneath the waves. And then there is the possibility of life long vanished. Fossils found in earlier cores revealed pollen, fragments of plants, and remnants of shallow water organisms that lived before the continent sank. These discoveries came from only a small number of sites. The remainder of Zealandia may hold traces of animals and forests that existed during warmer eras, when the land supported life similar to that of ancient Australia and New Zealand. Rare fossils may still rest within the sediment layers, protected by the quiet darkness of the deep sea. These fossils, if found, could reveal entire ecosystems that vanished without leaving surface traces. They could describe species that evolved in isolation, shaped by the continent's drifting path. They could show how climate shifted through ancient ages. They could hold memories of environments lost when the land sank slowly beneath rising waters. Yet retrieving such fossils is difficult. Drilling deep into the seafloor requires calm seas, advanced technology, and a measure of luck. Many promising basins are too deep, too remote, or too rugged for easy access. Despite these challenges, the unknowns do not loom as obstacles. Instead, they add a sense of quiet anticipation, a gentle openness to the idea that Earth always holds more than we can see. The gaps in Zealandia's story are part of what makes it so compelling. They remind us that a continent does not need to sit in the sunlight to be real. It can exist in partial understanding, its form suggested by fragments, its presence recorded by subtle signatures, its full story waiting in the depths. Each unanswered question about Zealandia becomes an invitation for future exploration. New technologies will one day map the seafloor with greater clarity. Future expeditions will lift fresh cores from unexplored basins. Scientists will trace the continent's hidden structures with increasing precision. And as these discoveries unfold, the silhouette of Zealandia will grow sharper, revealing not just a landmass beneath the sea, but a world with its own unique history. For now, the continent rests beneath its calm cover of water, holding stories that drift just out of reach. It is neither lost nor forgotten, but simply waiting, its unanswered chapters stirring gently in the quiet of the deep. As we drift deeper into the story of Zealandia, a quieter layer begins to form beneath the science. It is something that does not appear in seismic readings or gravity maps. It is felt only when we step back and consider the scale of what was lost. This submerged land was not just crust and rock. It was once a living world, shaped by wind and water, warmed by ancient suns, and softened by forests that rose and fell long before human eyes opened on this planet. Its disappearance carries an emotional weight that resonates through deep time, inviting us to pause and imagine what it means for an entire continent to vanish before memory could form. Long ago, when Zealandia stood high and green above the sea, no humans existed to walk its valleys or climb its mountains. There were no stories to record its rivers, no sketches to capture its landscapes, no words to preserve its seasons. The creatures that lived there moved through a world untouched by our presence. Their calls echoed in forests that no longer stand. Their shadows passed across clear streams and warm plains that have since been buried beneath thousands of meters of ocean water. What remains today are fragments, scattered fossils lifted from deep sediments, chemical traces in ancient minerals, tiny particles of pollen caught in layers of mud. Yet even these faint clues speak softly of a rich and vibrant world. Ecosystems flourish there, woven together over millions of years. They grew in isolation, shaped by the continent's drift across changing climates. Plants adapted to soils unlike any that exist now. Animals evolved with their own unique patterns, responding to conditions that shifted slowly through the ages. Some may have resembled creatures we know from Australia or New Zealand, distant relatives shaped by long separation. Others may have been entirely unique, leaving no descendants to stand in their place. Whatever form they took, these living beings filled a world that has completely disappeared. The thought of an entire ecosystem vanishing without a witness carries a gentle, haunting quality. It reminds us that extinction does not always happen with violence or sudden change. Sometimes it unfolds over millions of years, quiet and unnoticed. As the land sank, forests would have thinned, rivers would have stretched into marshes, plains would have become tidal flats, then shallow seas, then deep ocean. Life on Zealandia would have retreated step by step, pushed upward to higher ground until the last peaks were claimed by rising waters. Each stage left fewer places for the continent's life to survive. Eventually, nothing remained above the waves except the highest ridges, now seen as the islands of New Zealand. In this way, Zealandia holds a kind of silence that is deeper than the quiet of the seafloor. It is the silence left behind when a world ends slowly, leaving no survivors who remember its shape. The fossils found in sediment cores are like whispers from a time before trees fell beneath the rising sea. They offer brief glimpses of a vanished age, a pollen grain from a plant that once opened its leaves to sunlight, a shell from a creature that lived in warm, shallow water. These fragments are gentle reminders of lives that thrived in places we can no longer see. When scientists study these remains, they do more than reconstruct a geological history. They touch the memory of a world erased. They follow clues from ecosystems that ended not through catastrophe, but through the slow descent of land into colder, darker depths. There is a quiet poignancy in this process. The Earth did not intend for these worlds to be forgotten. It simply continued its deep time rhythm, lifting and lowering land masses in cycles far beyond the reach of human lifetimes. Even so, the emotional weight of Zealandia's disappearance lingers. It reaches across time because it hints at the vastness of Earth's story and the countless chapters we will never fully read. For every fossil found, there are many more that have dissolved or remain hidden. For every ancient forest identified through pollen traces, there are entire landscapes that left no imprint at all. These absences speak as clearly as the evidence we do have. They remind us that much of Earth's past exists only in shadows, shaped by forces that unfolded long before human curiosity took root. In one sense, Zealandia's quiet erasure is a natural part of the planet's evolution. Continents drift, climates shift, oceans rise and fall, life adapts or fades. Yet, in another sense, the story carries a gentle ache. It encourages us to imagine a world that lived its full life cycle without any eyes to observe it. A world of creatures whose final moments passed without witness, whose last forests sank beneath waves that would never retreat. The legacy of this vanished continent lies not only in the rocks and sediments that tell its story, but also in the space it leaves in the imagination. It reveals how fragile and temporary even the largest structures on Earth can be. It invites us to see the planet not as a static place, but as a living and evolving world where entire continents can rise and disappear without ever becoming part of human memory. And so Zealandia rests beneath the Pacific, carrying the emotional echo of a world erased gently, slowly, and completely, long before our species took its first breath. As we follow the long arc of Zealandia's story, it is natural to wonder what might become of this hidden continent in the ages still to come. After all, Earth is a planet of slow reversals. Mountains rise where seas once lay, valleys lift into plateaus, land long buried can sometimes reappear, carried upward by forces deep within the mantle. When viewed through the gentle span of millions of years, the surface of the world is never fixed. It shifts like a slow breath, lifting some regions while others sink quietly away. To imagine whether Zealandia might ever rise again, we must first look at how land is lifted in the first place. Beneath the crust, heat moves through the mantle in powerful, patient currents. These currents can push upward on sections of the crust, raising entire regions. Sometimes this uplift happens where plates collide, forcing rock upward like folds in a soft blanket. Elsewhere, rising plumes of warm mantle material can buoy the crust from below, creating broad plateaus or swelling highlands. Even the weight of glaciers or oceans can influence the height of land. When ice melts or water levels drop, the crust beneath can rise slowly, adjusting to the lighter load above it. These uplift mechanisms shape the world in quiet, steady rhythms. The Himalayas rise along the collision zone between India and Eurasia. The East African Rift, stretching like a scar across the continent, lifts and sinks regions in response to shifting mantle currents. In Canada and Scandinavia, land continues to rise long after ancient ice sheets melted away. These examples show that Earth is capable of elevating entire landscapes when the underlying forces align. Yet when we look toward Zealandia, the story becomes more delicate. This continent does not rest at the edge of a major collision zone. It does not sit above a strong mantle plume that could lift it. And it does not carry the thick, sturdy crust that resists sinking and responds readily to buoyant forces. Instead, Zealandia's crust is thin and stretched, weakened by the long process that led to its drowning. Even when parts of it rise slightly, other parts sink with equal or greater force, creating a balance in which uplift is quickly countered by subsidence. Some regions do experience small amounts of uplift. Along the boundary where the Pacific plate interacts with the Australian plate, there are zones where compression lifts slices of the crust. These areas include parts of modern New Zealand, where mountains such as the Southern Alps continue to rise inch by inch. This uplift is powerful enough to carve dramatic peaks and deep valleys, yet it affects only the narrow edges of the continent. The vast submerged interior of Zealandia lies far beyond the reach of these localized forces. In the heart of the continent, subsidence gently continues. The seafloor over Zealandia cools with time, and as it cools, it contracts and sinks slightly deeper into the mantle. This process has no urgency. It unfolds over millions of years, a slow settling that counters any upward motion that might arise along the margins. The weight of overlying water also presses the crust downward, maintaining a stable balance that resists significant uplift. The mantle beneath Zealandia offers little help. Unlike regions above strong mantle plumes, where heat rises and buoyancy increases, Zealandia rests above cooler mantle material. This cooler mantle does not provide enough upward force to lift a continent back to the surface. Instead, it supports Zealandia in a position stable enough to prevent sudden collapse, yet not buoyant enough to encourage a return to open air. There is also the shape and thickness of the continent to consider. Thick crust behaves like a raft on the mantle. If it remains strong, it can float high enough to rise above the sea. But Zealandia's crust is thin and stretched almost to the limits of buoyancy. It floats lower in the mantle than thicker continents. Even if some external force were to push upward, the continent would still sit deep, much like a raft that has taken on too much water. Its structure simply does not possess the strength required to lift itself back into the sunlight. Over the span of deep time, Earth could create new forces that alter this balance. New plate collisions might form, mantle plumes might emerge. Yet the likelihood of these events lifting Zealandia as a whole is faint. The continent is too broad, too thin, and too gently balanced within the mantle. At most, small sections may rise, forming volcanic islands or narrow mountain belts, as seen in New Zealand today. But the vast continent beneath will likely remain a hidden landscape, its valleys and ranges preserved in darkness far below the surface. This does not diminish its story. In some ways, the fact that Zealandia will remain submerged adds to the quiet power of its tale. It is a continent that lives in memory, evidence, and imagination. Its return to sunlight is not necessary for it to shape our understanding of Earth. Its presence beneath the waves reminds us that continents do not need to stand above water to be real. Their histories are written in stone, carried in sediments, and traced in the deep patterns of the crust. For now, Zealandia rests in its underwater world, steady and silent. And in deep time, while many landscapes will rise and fall, this continent will likely continue its life beneath the Pacific, a reminder that not all lost worlds are destined to return. As we reach this gentle bend in the story, Zealandia begins to feel less like an isolated curiosity and more like a quiet lens through which we can see the deeper nature of our planet. Its long descent beneath the Pacific, the fragments of its forests sealed in sediments, the traces of its mountains hidden beneath shifting currents, all reveal something profound about the world that carries us. Earth is far more powerful, far more fluid, and far more unpredictable than the surface calm we experience in our short lifetimes. To understand Zealandia is to glimpse the planet in its true scale. The crust beneath our feet behaves like a slow-moving skin, drifting and folding in response to the heat that rises from within. This motion is not violent in the way storms are, nor sudden like volcanic eruptions. It is quiet, steady, and immense. It occurs in spans of time so long that even the oldest trees cannot measure them, and yet these motions are capable of raising entire mountain chains or drowning whole continents in deep water. Zealandia's story rests at the heart of this truth. It began as part of a larger world, woven into the fabric of Gondwana. Over millions of years, the crust beneath it thinned, the mantle cooled and pulled downward. The ocean above it deepened, covering valleys and plains that once held their own ecosystems. It was not a sudden collapse, not a cataclysm that shattered landscapes in a single day. Instead, it was a slow yielding, a long surrender to forces that acted steadily, without pause or hurry. To witness this through the lens of deep time is to see Earth not as a fixed shape, but as something always shifting beneath its own surface. Continents can appear. They grow from arcs of volcanic islands. They evolve from fragments pushed together. They fuse during the quiet collisions of plates, and they can vanish. Some sink through thinning crust. Some fold beneath other landmasses. Some dissolve into fragments scattered across widening oceans. The map of Earth that we recognize is only one moment in a long sequence of maps, many of which no longer exist. In ancient ages, the continents formed single immense bodies. Later they separated, drifting like slow islands across the mantle. In ages yet to come, new landmasses will form, and familiar ones will fade or merge. The story of Zealandia teaches us that even the greatest structures on Earth are temporary. Mountains rise where the crust is pushed upward, but erosion begins almost immediately, wearing them down grain by grain. Oceans widen and deepen, then close again as plates shift direction. Forests spread across continents, only to vanish as climates change or land sinks. From the perspective of deep time, the Earth behaves like a vast, evolving landscape, always rewriting itself through gentle but persistent motions. And this rewriting is not simply geographic, it shapes life in ways we often do not see. As continents drift, they carry their plants and animals with them, isolating some species while bringing others together. Shifting climates sculpt new ecosystems. Uplift creates mountain corridors that life must navigate. Submergence erases habitats and forces evolutionary paths to change. Entire lineages have risen and vanished in response to motions that no living creature could perceive. Zealandia, with its sunken forests and lost plains, is one example among many, a reminder that life itself follows the rhythms of the planet. While the Earth feels solid to us, its deeper story is one of constant motion. We live on a world that never stops adjusting its shape. Every coastline is temporary. Every continent is a traveler. Every mountain carries the memory of a collision, and every ocean basin records the quiet spreading of crust at distant ridges. Even the land we know best is slowly moving beneath our feet, drifting across the mantle with a patience greater than any river. This understanding carries a gentle humility. It reminds us that the certainty we place in maps, borders, and landscapes belongs only to our brief window of time. The Earth we experience is not the Earth of the distant past, nor the Earth of the far future. It is a single frame in a long film, a moment caught between countless transformations that came before and countless more that will follow. What Zealandia teaches us, more than anything, is that the planet is never finished with itself. It shifts with heat. It folds under pressure. It rises where forces meet and sinks where crust thins. It holds within its depths the power to erase entire continents quietly, without disruption to the rhythms of life above. It can rearrange oceans and mountains, without ever revealing its intentions. Through this sunken continent, we see Earth not as a static home, but as a living world shaped by deep time, a world that grows, erodes, and renews itself, a world where continents appear and vanish as gently as tides, a world that is always rewriting its own map, long after our brief stories fade into the background of its larger tale. As we drift toward the quiet end of this journey, Zealandia settles once more into the soft darkness beneath the Pacific, resting exactly where it has been for millions of years. We have followed its story from the gentle rise of its earliest hills to the slow sinking that carried it beneath the waves. We have traced the fossils tucked inside its sediments, the magnetic lines pressed into its crust, the fractures that mark its long descent, and the delicate hints of life that once brushed across its forests. And now, standing here at the end of this long and sleepy arc, a simple truth rises gently to the surface. For all our tools and maps and careful measurements, there is still so much we do not know about the place we call home. Earth continues to hold secrets beneath its oceans, beneath its mountains, and even within the quiet spaces between tectonic plates. We walk across its surface believing we understand it, yet the vastness of deep time carries stories that stretch far beyond the reach of human memory. Zealandia reminds us that even an entire continent can slip from view, hidden not by distance or myth, but simply by the slow unfolding of geological time. This hidden land, once bright with its own ecosystems, tells us that Earth is still filled with corners we have barely explored. Every layer of rock contains a fragment of history. Every shifting plate carries a trace of ancient motion. Every grain of pollen sealed in sediment holds a whisper from a forgotten world. These are not grand revelations shouted into the sky. They are gentle reminders, subtle and patient, drifting upward from the deep. The farther we travel into stories like this one, the more we realize how delicate our understanding truly is. Our planet changes with a rhythm older than breath, older than stars reflected in the sea. Continents rise and vanish, mountains stretch and crumble, oceans open and close. And through all of it, life grows, adapts, flourishes, and fades in cycles far greater than anything a single lifetime can hold. To glimpse even a piece of that story is a privilege, a small window into a world that never stands still. As Zealandia continues its quiet existence beneath the Pacific, it invites us to step gently into that awareness. It reminds us that wonder does not require a clear view. Sometimes it is found in the unseen, in the landscapes we know only through scattered clues and soft data gathered from the deep. It teaches us that mystery is not the absence of knowledge, but the space where curiosity can breathe. And now, as we let this chapter settle into calmness, I would love to hear from you. Which part of this hidden world spoke to you the most? Was it the slow sinking of a continent over tens of millions of years, the lost ecosystems sealed within ancient sediments, the quiet recognition of a continent that eluded humanity for so long, or something else entirely? I truly enjoy reading your reflections. They remind me that these stories travel far beyond the screen, reaching listeners scattered across different time zones, different coastlines, and different quiet moments in their day. If you have found comfort in this soft journey through deep time, or if these calm explorations help you drift a little closer to rest, I would be grateful if you gently tap the like button or subscribed. It helps this peaceful corner of science reach others who might need a quiet story to end their day. And it lets me continue guiding you through more mysteries of our world, always at a slow and restful pace. For now, take a slow breath. Let your shoulders soften. Allow the story of Zealandia to settle like silt in calm water. And when you are ready, we will drift again into another hidden chapter of Earth's long and beautiful memory.